to recognize myself. Good. So it's 8 minutes to go. Yeah, here I am again.
Yeah, maybe it will work later on. Anyway, dear all, I welcome you to this fifth Advanced Fuel Stakeholder Workshop webinar. It's actually the first one as webinar, but yeah, we'll see how it goes. To next one. I'm actually Kristin Sternberg, coordinating the Advanced Fuel project on behalf of the Agency for Renewable Resources, or maybe better known as FNR. And in Advanced Fuel, next, we have assembled actually 8 partners from 7 different countries in the attempt to, our mutual goal is to analyze and investigate the main challenges that advanced renewable fuels face to a successful market rollout, and and try to develop strategies to overcome or at least reduce them. Here was we actually look at the whole value chain. And we do this in close exchange with our experienced advisory board, actually in person represented by Philippe Marchand, Ingvar Landelf, and Erik van den Heuvel, and also by regular engagement with the relevant stakeholders, like by organizing such workshop events. And this is all always related to a specific topic. The one of this workshop is about the end-use options of advanced renewable fuels and the connected challenges. And here you will hear some findings of our work. The project has already started its work in 2017, so I think we already can present you some interesting results, and we are keen of discussing those with you. And furthermore, we succeeded in gaining some external presenters as well, who will share some first-hand experiences, particularly interesting because they talk about the maritime, from the experience from the maritime and aviation sectors. So I really look forward to this webinar. Next. So there will be at first some organizational information to you as audience, because after each presentation we want to give you the chance to, or a couple of you, the chance to ask some specific questions towards this presentation. But we will also have a discussion session at the end, as you could, as you have certainly seen in the agenda. 45 minutes are allocated for this, and during the presentations, you always have time to type in some questions that will arise, or that might arise, in the question box, and we will then select some of them. We certainly, or we think we won't have time for all of them, but we will deal with the rest of the unanswered questions afterwards. But this will be a basis for the discussions that follow in the end. So please don't hesitate to ask us any questions that will arise. Next. So now I would like to use the chance to introduce you to Philippe Marchand. He's, as I already mentioned, in our advisory board, and he's actually very experienced in the topic that we will that we are about to discuss, because he had been working for the Total Group in the biotechnology and renewable energy division, and in his job he was responsible for the biofuel strategy for the whole group of this French major fuel supplier, and so he can certainly share lots of experiences. But for now, he will be our chair and watch the time and introduce you to the speakers. So Philippe, please, the web platform is yours.
Thank you, Kristin, for setting the scene so nicely, and good afternoon, everyone. So without further ado, we move now to the first presentation. The first presentation will be by Ayla Uslu from TNO Energy Transition, and she will present the results of a scenario analysis showing the role of renewable transport fuels in reaching GHG emission reduction targets. Now, a few words about Ayla. Ayla is a senior researcher at TNO in the Netherlands. She's experienced in the field of energy transition and renewable energy policy analysis, with a specific expertise in the analysis of the contribution of biomass and bioenergy to the EU climate objectives, and practical coordination and participation in numerous research projects for the European Commission and also for the Dutch government. Ayla's background is environmental engineering, and she has a master's degree on energy and resources. So, Ayla, the floor is yours.
Good.
Okay. First, I have to unmute myself. Can you all hear me well? I guess so. Thank you very much for the kind introduction, Philip, and good afternoon and welcome everybody. I'm hoping that in the course of my presentation, the system will go well and you can hear me good. As Philip indicated, I will be sharing with you an integrated assessment we conducted at TNO, and I was asked to keep it to 15 minutes, so I may be speaking quite fast. Next slide, please. Apologies for that in advance. I will start with a brief background to remind us the main problem, what we want to solve, and then I will say a couple of words about the approach, the methodology we followed in our study. Then I will move to the modeling results. I will share some of the results and then wrap up my presentation with the conclusions and the recommendations. Before I go into the content, I would like to define some of the phrases that I will be using so that we are on the same page. You will hear me saying Power-to-X, hydrogen and e-fuels. Power-to-X in my presentation refers to powered fuels, actually renewable fuels produced from non-biological origin as defined in the Renewable Energy Directive. This is basically electrolysis of water using renewable electricity to produce hydrogen, and when combined with CO2 capture, producing synthetic fuels, we name it as e-fuels in this presentation. Zero emission vehicles here refers to the electrification of road transport, direct or via hydrogen use, and zero emissions refers to the tailpipe emissions. Having said that, I will also indicate greenhouse gas emission targets. Here we refer to tank-to-wheel emissions. Within this study, we didn't look at the life cycle emissions, but only tank-to-wheel emissions. Next slide, please. As we all know, transport sector is the only major EU sector where greenhouse gas emissions continue to grow. In fact, according to the monitoring from the European Environment Agency in 2017, around 27% of the greenhouse gas emissions in Europe related to transport sector. Within the framework of Paris Agreement, all sectors in the economy needs to reduce greenhouse gas emissions significantly, so will the transport sector. What does it mean for us? With an advanced fuel project, we consider a sharp reduction in CO2 emissions from the transport sector, reaching to 85% reduction by 2050 compared to 1990 levels. And transport sector here refers to road and rail transport, inland shipping, aviation including international extra EU flights, but excluding international maritime. For the maritime sector, we introduce another 50% CO2 emissions by 2050 compared to 2008 levels to be in line with the strategy, for instance, published by the International Maritime Organization in 2018. The figure here in this graph represents the historical emissions from transport sector derived from the European Environment Agency. The dark blue line relates to transport excluding maritime, whereas the green line relates to maritime sector. Also, we plotted the targets for 2050 to illustrate how sharp the reduction will need to happen in the coming years. Next slide, please. The approach. In order to analyze the future role of renewable fuels, we consider setting up a scenario assessment because it can be, the greenhouse gas emissions can be reduced in many ways. And for this, we first define the main factors that are likely to influence the role of advanced biofuels, in this case, the most. And one of them is RESfuel technology development that may happen in the next decades, and also the diffusion of zero emission vehicles will become extremely important. Also, the availability of sustainable biomass is an important component and has been discussed for a very long time. That's an important factor in our scenario setup. Next to that, when we talk about zero emission vehicles, of course, we are talking about electricity and renewable electricity. This sufficient supply, continuous supply of renewable electricity with a reasonable price is another important factor in defining the future scenarios. Having said that, we set up two narratives. One is transport bio, a future where carbon reductions will mainly relate to biofuels. And the other side of the story is road zero, where we assume that zero emission vehicles will be the main instrument reducing CO2 emissions, and other RESfuels, including biofuels, will play a complementary role. In order to provide the data for these scenarios, we also constructed a reference scenario based on the PRIME's 2018 baseline, where policies introduced for the 2030 are implemented. What I mean with policies is that Renewable Energy Directive and the Energy Efficiency Directive, also the CO2 standards for light-duty and heavy-duty vehicles. We used a model called a Resolved Biomass Model, which optimizes the cost and define the least cost optimization to meet certain segments. In this case, it is not only transport, but also electricity, heating, and bio-based products are included. The model includes, among others, 16 types of vehicle fleet for the road transport. As renewable fuels, it includes biofuels, e-fuels, hydrogen, and direct electrification. Let's move to next slide. And the modeling result. Next slide, please. I will start with the greenhouse gas emissions, as this is the ultimate aim of this project, reducing greenhouse gas emissions. This figure represents the results of the scenario analysis for reference and road zero and transport bio. As you could see on the left side, according to the reference scenario, with the current policies, there will be quite greenhouse gas emission reductions. However, they will not be enough to meet the 85% target we indicated. In our scenarios, however, the emissions will relate to aviation and heavy-duty vehicles mainly. And when we move to the right side, you see the emissions from maritime and international aviation. And the reference scenario tells us that with the existing policies, those sectors will continue increasing their greenhouse gas emissions. And in our scenarios, when we zoom into our scenarios, we see that there will be some reductions. However, when we compare it with the 50% reduction as the vision of the sectors, we do not achieve. Next slide, please. This slide illustrates the underpinning information, how the greenhouse gas emission reductions happen. When we look at 2030, you could see the gray bars, which represent the fossil fuel. As can be seen, they are still the dominant fuel in the fuel mix, comprising around 85% of the total mix in 2030. And the remaining relates to biofuels, including biomethane and direct electrification. However, when we move to 2050, the picture changes quite a lot. All the colors pop up, which says that all renewable options, including biofuels in green, hydrogen in purple, e-fuels in orange, and direct electrification in blue, will be needed, and even more needs to be done to contribute to Paris Agreement goals. The blue line here, the direct electrification, is quite significant in Road Zero. In fact, it consists of more than 95% of the vehicle fleet in road transport to be battery electric vehicles, whereas in transport bio it's also high, it's around 8%. Another interesting observation here is the role of Power-to-X. Even with high biofuel deployment, as is in the transport bio, you could see that Power-to-X will be needed, and any delays in advanced biofuels deployment will shift further demand for these type of biofuels. What does it say to us? In both scenarios, the total of the Power-to-X hydrogen and e-fuels is around above 3,000 petajoules. And when we calculate the renewable electricity needed to provide this amount, we are coming to a number which is around 1,700 terawatt hours. And if you add up also the direct electrification, in case of road transport, Road Zero, you are getting a number that is much higher than the net electricity generation in Europe in 2070. So we are saying by 2050, you will need renewable electricity for transport sector, which is comparable to current total electricity generation, quite high. Next slide, please. Now we will zoom into the role of biofuels. Our results confirm the need for significant deployment of advanced biofuels, like similar to International Energy Agency. The figures may confuse you. As you can see in Road Zero, the biofuels, the amount is quite small when compared to transport bio. Nevertheless, when we look at the 2030, the increase compared to the current levels is significant. It needs to more than double by 2050, and it mainly consists of advanced biofuels. When we look at the transport bio scenario, in 2030, it comprises around 13% of the road transport, increasing to 38% by 2050. For the aviation and maritime, biofuel play a role of around 28-29% of the total demand in those sectors. And one may question, okay, I mean, in transport bio, you have a significant amount of biofuels, whereas in Road Zero, it is very small. One may expect that more biofuels should shift to aviation and maritime. There are many reasons behind, and one important reason relates to the progress in advanced biofuels. In Road Zero, it becomes quite slow. And one reason is, for instance, we are talking about biorefineries. Take pyrolysis oil. We are producing gasoline, diesel, jet fuels. And in Road Zero, the gasoline demand that needs to go to the market is already supplemented by electrification. So in the absence of such demand, this kind of processes become slower to move forward. Related to that, also the mobilization of feedstocks become quite slow in this scenario. You cannot assume from one year to another year all biomass is to be utilized. When they are introduced late to the market, also their progress becomes quite limited. In terms of modeling in maritime sector, different than the road transport, we had to rely on Prime's 2018 projections for the fossil fuel. So we defined the distribution of biofuels among those fossil fuels. And according to that scenario, for instance, LNG will be around 11% of the total. And in our assessment, 90% of the LNG will be bio-LNG. And that scenario did not include other supply options. For instance, methanol is considered as a promising option. If it was in the projections, the picture might have changed. When we look at the aviation, the story relates to the limited amount of available biofuels that can meet the needs of the sector. Next slide, please. In this slide, we detail further the biofuels according to the type of fuels. Even though advanced biofuel focus on lignocellulosic feedstocks, we looked at also the other options. Light blue is first generation biofuels, both diesel and ethanol. And the dark blue is used cooking oil based biofuels. The light green relates to gasification, and the dark gray is pyrolysis and hydrothermal liquefaction, and the orange color relates to biochemical routes, meaning lignocellulosic ethanol production, but also alcohol to fuels, and anaerobic digestion to produce biomethane and bio-LNG is part of that group. And I mean, I can tell you lots of things, but more importantly here is that by 2050, more than 70% in case of RESfuels and more than 90% of biofuels are to be lignocellulosic feedstock based, according to our assessment. Another conclusion is that in transport bio, the demand in transport sector is limited by the potential. We see that the majority of the feedstock, more than 95% of waste of forestry feedstock are utilized in this scenario. So mobilization of European sustainable biomass potential becomes increasingly important to avoid unsustainable practices in the future. Next slide, please. And conclusions and recommendations. I have 1 minute, so I managed to respect the time. One of the conclusions is that the intended targets, in fact also the Paris Agreement, is very challenging and require not only deployment of all renewable options, we are not talking about either all, but all, but also an increase in efficiency and reduction of energy demand in transport sector. Hydrogen and e-fuels appear beyond 2035 in our model, and they do not necessarily appear because they are the least cost optimization supply options. However, because of the slow progress in other technologies, and they contribute to fuel mixes of heavy-duty vehicles, maritime and aviation sector. The scenarios indicate the 2 important pressure points for the future. In case of RESfuels, it's mainly power sector, and in case of transport bio, it is the availability of sustainable biomass resources. This study indicates minimum of maximum range of biofuels, and even in case of a minimum range, we are talking about a 165% increase, going up to 700% increase in transport bio. When we look at the installed capacities needed, we are talking in the range of 350 plants to more than 1,000 plants in another scenario. And more than 70% of biofuels consist of advanced biofuels from lignocellulosic feedstocks. Next slide, please. Next slide. Yeah, recommendations. Given the conclusions, the first recommendation is that future policy measures need to be strong enough to ensure that significant amount of RESfuels and also zero emission vehicles are deployed. These need to also go hand in hand with energy efficiency improvements in this sector and demand side management. This is a cliche, I know, but there is no silver bullet point to solve the problems. So a balanced set of options and development of new conversion routes will be needed to avoid pressure on feedstock markets and also on power sector. One of the options to reduce the pressure on feedstock markets is actually production of lignocellulosic feedstocks on marginal lands, energy crops. My colleagues from Utrecht University and ATB has done a great work on looking at the marginal land up to 2050 in Europe and what the potential and the environmental consequences are. So I will recommend you to visit that work. Another option is that policies from a transport perspective could prioritize biomass use to this sector. Such a prioritization will reduce the future demand for electricity from transport sector. And another recommendation is that enabling renewable fuels to aviation sector certainly needs processes to increase jet fuel production within the biorefineries, so dedicated support needs to be given to that. And last but not least, a combination of policy measures such as the quota obligation, which is the current practice maybe coupled with a feed-in premium, can be recommended to provide secure and reliable market conditions, particularly for advanced biofuels to be used in aviation and maritime sector. Next slide. I would like to thank you for your attention on behalf of the team that has worked on this project, and I will recommend you to visit our publication where you will read more about the details of this study. Thank you all.
Thank you, Ayla. That was very interesting presentations. I think we are nearly on time, so we may have room for one question or two questions. Kristin, do we have any questions from the floor?
No, we actually don't. You could use dear audience, please use the opportunity. Are there any questions in regard to this presentation? There are no raised hands yet.
Okay, if we have no question, I will ask my own just to initiate the process. Now, you've told us that there would be a pressure on domestic biomass in Europe. How about using algae as a local resource for lipids? That would help to support the already developed HVO pathway, which is mature and reasonably cost competitive. And it would also help the ailing fishing sector.
A great question and comment, Philip. Within ADVANCEFUEL project, as the target was focusing on advanced biofuels produced from lignocellulosic feedstocks, we did not focus on other options, including algae, and certainly algae can play an important role in the future for biofuels, next to for pharmacy and bio-based chemical production routes. On top of that, other than algae, of course, you can produce oil crops on lands that are not used, non-edible oil crops as well. So there are many other ways indeed, but as I said, within the framework advanced biofuels, we limit ourselves to lignocellulosic feedstocks. Certainly you can expand it. Nevertheless, this land-based pressure needs to be taken into account.
Thank you, Ayla. So I think it's time now to move to the next presentations, and we will hear now about the status of conversion technologies. And for this, it's my pleasure to introduce Stavros Papadokonstatakis. Stavros is Associate Professor in the Division of Energy Technology at Chalmers University of Technology in Sweden. Stavros is conducting research on process systems engineering, techno-economics and sustainability aspects of process design, with a focus on biorefinery, carbon capture and sequestration, carbon capture and usage, industrial symbiosis applications. So this way helping to design the next generation of chemical plants. Stavros holds a professional chemical engineering license since 1999. He's also a senior member of the American Institute of Chemical Engineers since 2014. And he's also Sweden's representative in the computer-aided process engineering working party and a member of the energy section of the European Federation of Chemical Engineers. So quite qualified to tell us about conversion technology. So Stavros, please.
Thank you, Philip, for the introduction. I hope you're hearing me well. So the title of this presentation mentions status of conversion technologies. And by status, in this case, it means mainly production costs of the investigated technologies within our project. As Ayla mentioned, we limited our study into lignocellulosic-based conversion technologies. I will present you the current status, then the scope for capital expenditure reduction, and also how this scope for reduction can be further enhanced by integration into infrastructures. Next slide. So about the current status, in this quite busy slide, I think the first thing that we can see is that if we compare the production cost of, with all the uncertainties, of course, of current technologies with the prices mentioned for fossil fuels, we will still see a gap which means that from cost perspective, at the current status, with the current policy instruments, the current CO2 taxes and the prices of these fuels, these technologies are not competitive. And so part of the project was to see what is the scope for reducing the costs of these technologies. And then we can see in the lower right the cost breakdown for this overall production costs. And we see that capex is perhaps ranging somewhere between 35 and 45%. Feedstock perhaps similar range, and the other operating costs are quite lower. This shows that for most of these technologies there is a certain degree of optimization, you would say, which means that from the efficiency perspective you cannot expect too much in the future. Perhaps one exception is the ethanol production, not so much in the turnover of biomass to ethanol itself, but in the utilization of other byproducts that are currently have quite low added value in the production costs or in the profitability of the plant. So we didn't focus on the biomass price because on the feedstock cost, because clearly, since if there is not a lot of potential of increasing the efficiency, then it's a matter of biomass price. On the other hand, on the capital cost, in order to kind of unify the analysis between the technologies from the different studies, we used economic parameters as those shown on the upper right, which has a range for size of plant capacity based on what we believe, based on some plants operating today, demonstration or commercial plants, of what we believe is an optimal or near optimal size of production, with a feedstock cost range of 15 to 20 euros per megawatt hour, and the plant economic life around 20 years. It has to be stated here that this analysis was independent, let's say, from a very recent report of International Energy Agency, and it was nice to see that two independent studies result into, most of the times, into similar ranges for the current status, at least, of the production. And we will see that they also move into similar trends for the scope of capex reduction. Next slide. So the main conclusion, as I mentioned, is that there is a gap compared to the fossil fuels, that perhaps this gap can be closed at the beginning by subsidizing, but it cannot be a forever policy. Subsidies of bio-based fuels. The feedstock cost is a large share of production, and this can have, since this is dependent on the biomass price, on the price of the feedstock, we have to consider that as these technologies become more competitive, perhaps, or more used in the future, this perhaps will have an implication on the feedstock price itself. On the other hand, I have to say that in the previous slide, the feedstock price was not considered as a price, for instance, for waste biomass. The waste biomass is another case, and the price of this biomass can be substantially lower. The question is how much of this waste biomass would be available. At the end of the day, it's important to note that high capital cost implies high financial risk, so it's quite important to see what is the scope of reducing this capital cost. Next slide. And to do this, again, we did an independent study, independent from the study of International Energy Agency, but after seeing also the report, we saw that we more or less we had similar conclusions. We did a bottom-up study based on the so-called multi-component learning curve theory. This means that every conversion pathway that we analyzed was was divided into multiple process components, and for each process component, parameters of the learning curve theory framework were assigned. There is, of course, some uncertainty in these parameters. That's why also sensitivity analysis was done during the study. And an important thing is that an important parameter of this study is what kind of annual growth are we expecting. And this was also, I think it was clear also from the previous presentations that there are multiple scenarios of what you can expect for targets of biofuels in the horizon that we investigated up to 2050. I will show you, I will mention results of two main scenarios. The one is on a current, more conservative trend of annual growth. You see, for instance, annual growth factors of 5 to 10%, and the other would be on a more ambitious growth rates. On more ambitious growth rates, perhaps going to the direction of 20% of fulfilling targets of 20% of biofuels in future transportation consumption mixes. Next slide. This is the scope of the capex reduction, which in the ambitious scenario, we can see that perhaps we can expect capex reduction up to 40%, while in the less ambitious scenario, or let's say in short term, this can be limited to 10 to 20%. If we observe the lines for the different conversion pathways, we can see that perhaps the more steep line is for the ethanol production from fermentation, which is, let's say, on the upper scale of the level of 40% compared to the other technologies. What this specific capital expenditure is combined, of course, with big cumulative installed capacities. You see ranges from 100 to 700 gigawatts. This is translated for the plant size that I mentioned before, perhaps to some thousands of plants, so operating with full load hours. And the learning comes from know-how of assembling these plants mainly. It's always, of course, a question of it's always a question of if there is enough place to install these plants, if there is the logistics can support this biofuel production, and where in the world, in Europe or away from Europe. And this is also related perhaps to the next slide that we can see. Next slide. Which is if perhaps we can start thinking of utilizing existing infrastructures in turning them into biorefinery plants or biofuel plants in the future, rather than thinking that we are going to have these infrastructures plus installing new plants. There has been an analysis has been performed at Chalmers that shows the potential of integrating biofuel production into some ways into existing plants, like co-processing feedstock in crude oil refineries, co-allocating first and second generation bioethanol plants, or even transforming current systems that are used for gasification systems that are used for district heating, transforming them into gasification plants for biofuels. Next slide. And this is also my concluding slide. We have to think that if we are moving to a decentralized scenarios and not to just allocating a couple of plants or some dozens of plants somewhere in Europe, perhaps where most of the biomass supply is in the north, perhaps, or Central Europe. So if we're not thinking about this, but we're thinking about decentralizing the plants, we have to think that some of the countries in Europe, they don't have at all a biomass infrastructure. So it could be important to think that to reach some stones, we could start to reach some targets. We could start by some stepping stones for those cases that there is no infrastructure, to just start thinking about other kinds of biomass utilization first, perhaps in combustion or substituting coal plants. So that later these plants can be replaced by pyrolysis units or by gasification plants or something else in the next transition stage. One way or the other, it will be important to use existing knowledge and know-how of thermal processes and biomass handling in making this transition and utilizing infrastructures to have the additional benefits on capex reduction. Next slide. And I would like to thank you, of course, the whole Chalmers teams who worked in this project. My colleagues Paraskevi, Eva, and Philip, for that, who participated in the Advanced Fuel project. Thank you very much.
Thank you, Stavros. That was very clear. Kristin, do we have a question from the floor? Okay, I don't think we have a question. So I will fire one question to you, Stavros. Of course, we will hear later in this webinar about the policy needs.
Sorry, Philip, I was muted. Sorry. No, we don't have an answer and no raised hands. So yeah, sorry.
Okay, I lost my question then. Now, it's very clear from your presentation that we are facing nearly forever a cost issue with biofuels. And do you think that we should all get involved today in a very strong advocacy in favor of investing in new biofuels manufacturing facilities as part of the sort of trillion-ish euro recovery plan post-COVID-19? So this way, that would be a possibility for the depreciation cost, which is quite significant, as you've shown, not to be part of the premium.
Yeah, this is interesting. Of course, I have to say that in our analysis, we kind of kept the macroeconomic environment constant. So as you have seen, we have used constant interest rates, or we haven't considered, for instance, as the technologies evolve, perhaps, or through policies, a better access to capital that could increase costs in this way. So the analysis that I presented, the costs that I presented, were very much focused on technical aspects of capital costs. I guess there are other factors, and what you mentioned is can be a way also for decreasing further capital costs, as you mentioned. Yeah, but this was not the main focus of our analysis. It was mostly a technical analysis.
Okay, so now we know how to produce biofuels, what also they can bring to the reduction of the carbon footprint of transport. So now we need to understand how they fit with the internal combustion engines, which is still the equipment of most of our land vehicles. And for this, I would like to welcome Michal Wojcieszyk from Aalto University. Michal there is a doctoral candidate. He's doing research on alternative fuels in the group of energy conversion. Michal graduated in 2014 in Bachelor Studies of Nanotechnology, and then he completed with honor the joint Nordic Master Degree Program of Innovative Sustainable Energy Engineering, both in KTH and Aalto University. So Michal, when you're ready, go ahead.
Okay, so thank you, Philip, for the very kind introduction. Hello, everyone. Today I will speak about advanced biofuels, their properties, and also the vehicle compatibility. And maybe next slide, please. Yeah, so this work was done during the Advanced Fuel project, and it was task 5.4, which concentrated on fuel and fuel blend properties in end use, led by Aalto. Next, please. And the research and the work was conducted in the group of energy conversion at Aalto, headed by Professor Martti Larni. The group deals with all topics related to energy issues. Next, please. And in the Advanced Fuel project, which covers the whole value chain of advanced biofuels, starting from the feedstock through the conversion, finishing on end use. So our role was concentrated on end use and various transportation modes like road, marine, or aviation. Next, please. So due to time restrictions, I will directly go to the structure of the problem and our task we face in the beginning of the Advanced Fuel project. So on the left-hand side graph, so you can see the task and the structure. So on the one hand, we have the fuel properties, which are very essential when we consider the end-use performance. And on the other hand, we have the engine performance, which is related to the engine type and also to the fuel properties. And depending on the engine type and final application, so then we can distinguish essential properties for various transportation modes, what is collected and presented in the table on the right-hand side. Okay, so next, please. And few words about the developed methodology at Aalto, so how we approach the task. So we try to evaluate and assess the advanced biofuels from the whole fleet perspective. And as I mentioned, so the properties were the key parameters when analyzing those fuels. And as an output, so we consider the end-use performance of alternative fuels such as fuel consumption or CO2 emissions. And in between, so we can see this black box, so that kind of modeling methodology we applied together with this multilinear regression. And as a result, so we correlated a set of known fuel properties for the advanced biofuel with the end-use performance. Next, please. And the results, so I think that's the most interesting part of our work. So I will briefly explain the results, and then I will show also the highlights from our modeling work and give some recommendations. So as you can see in the graph, so we considered various modes of transportation, so from air and land and waterborne, and various transport sectors. And we developed the various models for different modes of transportations. What's important to remember that different engine technologies are needed depending on the transport sector, so on its final application. And also one important thing we should consider is the fact that drop-in fuels, so they are still preferable options when we consider renewable or advanced biofuels. Okay, next, please. So after a very short introduction of our modeling methodology, so I can refer you to our recent publication. So there you can find the detailed described methodology. So there are technical and journal papers, also master thesis and reporting for the EU Commission. Next, please. But I will go to the examples of our modeling work, so I think that would be the most appropriate over here. So the first example explains the behavior of advanced of alternative fuels for light-duty vehicle fleet, and here we have more specifically spark ignition engines. And the model, which is presented in the upper part of the slide, so represents how the fuel consumption is changing for alternative fuel, which has specified and known fuel properties. So in that case, when we considered spark ignition engines, so we have some key parameters as density, heating value, research octane number, and oxygen content. And in our study, we considered various alcohol blends which were presented before, so ethanol, methanol, isobutanol. And what is also important when we analyze this equation, so here we have the relative changes referring to the reference fuel. So the reference fuel in that case is gasoline, and all the properties and also the end-use performance is expressed in relative change comparing to this reference fuel. And the result of our modeling work, so you can see the validation on the right-hand side graph, where the dark squares represent fuel consumption data from the literature, whereas the red dots are representing the modeling outcome, so how model predicts let's say the performance, in that case the fuel consumption, for various fuel blends. And as we can see, the prediction is pretty high, so the model accuracy is very good. And also the conclusion out of this modeling, when we look at the whole fleet, so for higher alcohol blends, then of course we have higher fuel consumption, but we observe the potential for a lower tailpipe greenhouse gases emissions and also better efficiency. So that's very important outcome over here. Okay, so next please. And in the very similar manner, we proceeded with various transportation modes. So before I presented for the light duty vehicle fleet, here is the heavy duty vehicle fleet and compression ignition engines. So here the fuel consumption for the alternative fuel can be, let's say, predicted based on known fuel properties such as density, heating value, or cetane number. And fuels which we considered in our study, those were the high quality paraffinic diesels. So this is like, for example, the biomass to liquid fuels or hydrotreated vegetable oil, which show lower greenhouse gases emissions. I mean here the tailpipe emissions, but also the local emissions are significantly lower. On the other hand, we also consider the traditional biodiesel fuel, so the same type of fuel. And here we should remember about the blending wall for those type of fuels and their blends with reference diesel fuel. And again, the validation on the right-hand side on the graph you can see for various fuel blends. Okay, so next please. Okay, so the third example which I wanted to show you is about marine engines, and here we were considering again diesel-like fuels, but here we had a little bit wider palette of choices. So here we consider straight vegetable oil or same type of fuel, then HVO again, then alcohols such as methanol, very good representative, then pyrolysis oil and hydrothermal liquefaction biocrude. And what we could indicate, so that's very good options from our perspective. So the first one is the methanol. It's like the very good potential marine fuel. So looking at the infrastructure and also the engine technology feasibility. So there are already some demonstrations in the market, for example, by Wärtsilä or MAN. But we need to remember that we need a dedicated engine technology for the methanol. Then the biocrude from hydrothermal liquefaction. So very interesting also, again, conversion process for the lignocellulosic feedstock. And after some upgrading, we could potentially use it as a drop-in fuel for the marine application. But of course, the further R&D should be done in that respect. Okay, next, please. And the last example over here, so it regards the jet engines. And here we have already 5 certified sustainable aviation fuels and related conversion pathways, so including the Fischer-Tropsch, so again, BTL-like fuels, then HEFA fuels, or alcohol to jet from isobutanol or ethanol. And here we have also the blending wall, and the blending wall is like usually 50% for those fuels, except synthesized isoparaffinic kerosene. Okay, so next, please. All right, so I would like to conclude my presentation with those 4 main points. So during our work in Advanced Fuel project at Aalto, we developed 7 models which cover various modes of transportation. And we came to the conclusion that field properties are essential in assessing vehicle compatibility, and also knowing the set of physical and chemical properties of advanced biofuel, we can predict the end-use performance, for example, in terms of fuel consumption. Of course, drop-in fuels are preferable options due to compatibility issues, but of course, engine modifications are feasible. That's the case for ethanol in light-duty vehicles or methanol in the marine sector. And I would like to conclude with that renewable energy source fuels have really the potential to outperform fossil fuels in terms of greenhouse gases emissions and local emissions, thermal efficiency, and even fuel economy. So that's the final conclusion. Next, please. And the last few words about the tool. The online tool is which contains all the results from our modeling work, can be accessed by free registration. It's online, so you can find it on Advanced Fuel website. So here you see the authors of the tool, and you can test various alternative fuels in different transportation modes based on the developed methodology. Okay, so next, please. And with this, I would like to thank you for your attention.
Thank you, Michal. That was very clear. Same as for the previous presentations. Do we have any question from the floor, Kristin?
Yes, we actually have one directed to Michal, and it says, "What's your opinion?" Or "What's your opinion? Should motor technology be chosen and fuels be forced accordingly, as politics is currently advocating?"
Oh, Kristin, could you please repeat the question, because I couldn't hear clearly the question.
Michael Winkler is asking, what is your opinion? Should motor technology be chosen and fuels be forced accordingly, as the politics is currently advocating?
So from my perspective, I think it's very, let's say, very flexible market. So of course we can indicate the technologies and fuels which are, let's say, appropriate from, let's say, end use perspective, but then also the costs, that's kind of very important factor. And what Stavros was explaining, so there is still the huge gap between those fossil-based fuels and let's say advanced biofuels. So I would say we could select the alternative fuels, of course, that is needed to indicate which are, let's say, the best option from the end use perspective. But then we need to also take into account other aspects, and that's, I would say, always kind of trade-off between, let's say, competing factors in that respect. I'm not sure if I answered correctly the question, but
yeah, it's yeah, we can't ask Mr. Winkler now. That's a pity. That's an advantage of raise the hands.
Maybe we can during the discussion part of this webinar.
Yeah, exactly.
Okay, thank you, Michal.
okay, thank you very much.
You're welcome. We have one final presentation before the break, and then we will listen to Erik van den Heuvel. Erik is director of the Dutch platform for sustainable biofuels, and he will dive in the role of biofuels in the maritime sector. Just a few words about Erik. He's a very, very senior expert in sustainable energy, with a focus on business strategy and innovation on biomass and waste and residues usage. Developed over 25 years of management experience on an international basis. And that experience has been recognized by several strategic assignments for the European Commission, the Dutch government, etc., etc. In March 2015, Erik has founded the Studio Gear Up, an independent firm that is supporting organizations in the transition to a low-carbon economy and providing strategic advice, process and project management services, guiding and facilitating stakeholder involvement processes. Erik holds a master diploma on technology innovation management from Aalto University of Technology and a postgraduate diploma on strategy and innovation from Oxford University. So Erik, my pleasure to give you the floor.
Thank you very much, Philip, for your very kind introduction. Welcome, everybody. I assume I'm well heard, and I would like now to take you into the role of biofuels in the maritime sector, and I'll give you some background on how the platform in the Netherlands is working on this. Next slide, please. Just to give you a key takeaway message, if you for some reason have to leave early, biofuels are, I think, already a very cost competitive low carbon fuel option in the shipping sector, and they contain no or only very limited sulfur. So in that sense, they already contribute also to these, let's say, non-CO2 issues, non-climate issues. However, I think what is seen, and we saw it also by Michal's presentation, I think, and we will hear about later on also from Rianne de Vries from Goodfuels, an actual dedicated marine low carbon fuel has not yet been developed, or you could say it is still under development, and it needs to fit to the fuels that are in the place. They are all fossil, so perhaps indeed also engines need to adapt to the new fuels. I think an important set of design criteria for such dedicated marine fuel is that it actually should be based on an extensive feedstock base. And Ayla shed some light on which feedstocks could be, let's say, the majority in the way towards 2050. It needs to have a price competitive conversion. It should be compatible with existing engines. New engines and new vessels would actually give new options because you can co-design them. If these fuels are being produced in biorefineries, actually you can create multiple markets and supply from multiple markets, and I think that gives a robust technology strategy as well. And at the same time, and we've heard already a bit about it, about e-fuels or electrofuels or even e-refinery, so e-chemicals. I think where we are not yet fully understanding the synergy development potential between biofuels and electrofuels. Okay, next slide, please. Very brief, the Netherlands platform is an independent knowledge and innovation platform on biofuels and renewable fuels for transport. It was initially financed by the Ministry of Infrastructure and Water Management, who also wanted to have a communication channel with the sector, like it had with electric mobility and hydrogen mobility, or LNG. It is an association of sector players, only founded about 3.5 years ago, but very much involved in well, addressing, let's say, societal needs. And its mission is also reducing the climate impact in transport, stimulating the demand and deployment of renewable fuels in their production, but at the same time enabling also the build-up of a bio-based economy. Next, please. The Netherlands is a very typical country, small, but as a result, and because of its harbors and its refinery clusters, it is the shipping sector is a very important sector. What you see here in these two pie diagrams is the energy consumption on road, let's say on the Dutch territory, which is in blue, and let's say the international bunkering, which goes to shipping and to aviation, and that's in brown. And what you can see here is that from 1990 till 2018, it actually grew substantially. But what you can also see is that the international bunkering outnumbers the use of energy used on Dutch territory. So the shipping sector, in fact, is even the amount of fuel that we supply to the international ships and vessels is larger than what is used on road and rail in the Netherlands. And for that reason, it is a very important issue that the Netherlands is looking at how to address the transition to low carbon fuels, especially when you see that many of the climate agreements and climate actions that are being taken are only looking at Dutch territory, so the blue parts of this diagram. Next slide, please. Here you can also see that the Netherlands also is very important in the European market. About 1/4 of all fuels bunkered into the maritime sector is bunkered in the Netherlands. Spain, Belgium, and to a lesser extent Germany are the other top 4 players. But it also shows that the maritime sector is very important for these, let's say, countries. So if you want to address climate neutrality, you have to tackle also the shipping sector. In the table, you see that, let's say, the energy used for international shipping is about 1,850 petajoules. And that actually is quite stable. It decreased a bit. We saw that in the diagram by Ayla. But suppose the EU will have actually also a 14% renewables target for the shipping sector, which, for instance, is now also proposed for the Dutch aviation sector. But if EU would have a 14% renewable target, that would actually equal about 260 petajoules. We have addressed that also in the current proposed directive on the Fuels EU Maritime Initiative. If you want to do that, 260 petajoules sounds a lot. At the same time, we have seen the numbers, and we know that the total obligation of renewable fuels in the RED II for 2030 is in total about 2,000 petajoules. So this would add about 13% on top of what we already have to do to start pushing for more renewable fuels, and I think that biofuels will have the best position here. Next slide. Of course, it's all about CO2 emission reduction, so actually to reduce the climate impact. And then in this study here, you can only see that there is a whole range of options and technical measures that you can take to actually bring down the CO2 performance of vessels and ships. And I think in most cases, they all have to, let's say, work together. You can really combine them. But on the red graph, actually shows that biofuels by far have, for the measure itself, a very important CO2 emission reduction potential when you replace fossil fuels with bio-based fuels, especially those with a high greenhouse gas reduction potential. And next slide, please. Within the platform over the last years, we have addressed shipping on a regular basis. Interesting point here, I give you here some 3 reports that, let's say, under the let's say, commissioned by the platform have been developed. The first one on sustainable marine biofuels in the Dutch bunker sector, that actually said that an opt-in or an obligation will actually favor utilization in shipping over aviation and road. I will show that in the next slide. Of course, we have to make sure that it is additional rather than, let's say, being replacing, so that we shift fuels from one sector to the other. It needs to expand. In 2018, E4Tech executed a report that actually said there is a wide range of biofuel options that exist, and there is a different status of how much they fit with drop-in regulations. And early this year, end of last year, we actually held a stakeholder consultation on request by the Ministry of Infrastructure and Water Management on what should the Netherlands start preparing some kind of measures for introducing renewable fuels in the shipping sector. And it became very clear by the stakeholders that if well, the sector itself actually declared it needs any kind of measure to make sure that the deployment of renewable energy in shipping is going to really kick off. Without that, it's very difficult because the sector is a very different sector compared to aviation or to the road transport sector. The margins are very thin and adaptations are very well, costly, and especially when capex is high, people are very conservative or cautious in this case. Next slide, please. This was indeed the report showing in the light blue that under this is for the Netherlands situation, just a scenario using the resolve model, one of our trainee students, that actually under RED 2, most of the fuels would actually flow and substitute road transport and flow into the aviation sector. So there is no additional benefit. There's just another sector that's going to use the fuels, mainly advanced fuels and let's say conventional fuels. Next slide, please. This is from the E4Tech report indicating the various biofuel options for deep sea shipping. On the y-axis, you see how well they are compatible to the existing engines. And on the right-hand side, you see the readiness of the fuel production. And in some cases, you actually can see that the position of today's situation is stated towards where they might move when we actually start building those technologies towards 2030. And of course, the preferred position in this graph is being on the right-hand side and then on the top side, because then it's and compatible and readiness. Methanol has been mentioned, HVO has been mentioned as potential fuels. Greenhouse gas emission reduction, the darker the green color, the better. But of course, that really always depends on the feedstocks. So I think on the HVO side, it could even be much higher than presented in this diagram. Next slide, please. So what should be on the roadmap agenda? I think we have to really bring forward to policymakers, but also both at EU level and at national level, that there are still technical, economic, and operational barriers to the use of biofuels in shipping, even though they are, as compared to zero emission options or hydrogen options or other battery electric vehicles. I mean, their adaptability to ships is far better than many of the others because of the high capex requirement and the impacts on, let's say, amount of carriage capacity of the fuel of these vessels. Yet these barriers still exist. We have to take further actions on developing dedicated marine low carbon fuels. We need to make sure that we have access to the resources or build availability. We have to have dedicated technology development to bring down these marine engine fuel conversion technologies. And I think we should integrate it in a biorefinery business case. At EU level or at national level, we really have to start developing instruments like obligations to make sure that EU also has a leading role in this, because IMO targets have been set. Ayla mentioned them, but I mean, for EU and for the Netherlands, there is something at stake here. Next slide, please. See, I'm done, just in time.
Excellent, Eric, just in time, perfect. I think we've got an interesting question from the floor. Kristin?
No, we don't have a question. Sorry for that, but you surely have one prepared.
Actually, can read one, if I may.
Oh.
Eric, if I may ask the question.
Yes, please.
Michael Winkler, who asks, an example of co-development of fuel and ships has been can be seen with the low sulfur fuels. It did not happen when 2014 IMO decided to limit the sulfur content below 0.5. What do you think would be the useful policy steps for initiating this co-development?
Yeah, that's a good question. I think, well, of course, I mean, this is you could take the example of, let's say, a printer with a cartridge. You can only print a piece of paper if the printer also contains these cartridges of color, of ink. And I mean, without the other, I mean, if you only have the cartridge, it cannot work. If you only have the printer, it doesn't work either. So there are in mobility, you need the engine, the vehicle, or the vessel, and you need a fuel to actually make sure that this is converted well. And what I do see is indeed that there is hardly, as far as I know at least, there's hardly kind of a co-creation on optimizing, let's say, an engine that completely fits to specific characteristics of the fuels. And the interesting point, I mean, in road transport, you could say, well, that's very difficult because it really is optimized. The low, I mean, there are large numbers, so it's very difficult to make these adaptations. But on ships, of course, you could imagine the amount of ships that are operating in the world. I mean, there are quite some numbers, but still, I mean, they run for a long time. They're built to last. You can really co-design ships, and perhaps you have to find niche markets where that actually goes, so that you can demonstrate proper operation of a co-designed engine fuel combination. And perhaps you have to actually start thinking of vessels that operate within the European waters only. And so to really find where can I demonstrate it, that you optimize it, because now we always have the problem that either the engine doesn't fit well to the fuel I have available, or the fuel doesn't fit to the engine that I have available, and well, that then ends with nobody acting at all.
Very well. I think there's another interesting question about whether the biofuels would be a real player or just a transition fuel in the transition to a low carbon maritime segment.
Yeah. Okay. Yeah, that's a good question. I think, well, somehow I think, well, let's say, I'm happy with the term transition fuel, because nobody knows exactly how long the transition will be. The problem with the transition fuel being, let's say, qualified as a transition fuel is that people say, well, why should I invest in it if it in the end is overtaken by something else? And so I think we have to take a broader look to this and say, well, my understanding is that the shipping sector, as also the aviation sector, as well as the long distance road transport sector, actually favors high energy dense liquid or gaseous fuels to be, let's say, the fuel of preference for a very long time. The thing that we have to adapt is, let's say, its carbon intensity. In that respect, I think there is also multiple options that can develop this, but we've also heard that, for instance, e-fuels might not come to the market before 2035 from a cost-effective point of view, or from, let's say, the capacity production point of view. So if transition is meant that we will, let's say, start developing from what you have, so have process innovations and optimization, then biofuels are available, and they are pushed now out of the road transport sector, especially light duty, because of the introduction of electric mobility. So use that, adapt your system to that available system, expand your total volume by setting up well-designed supply chains, and from that continue on improving. And then e-fuels might take over when, I mean, nobody will ever tell that all shipping fuels or all aviation fuels will be only biofuels. I think there will always at that time then also be the need for e-fuels or whatever, or hydrogen, or but before we reach that moment, I think there's a significant and a relevant share of biofuels that plays a part in it, and perhaps it will stay for quite a long time. I mean, I have no clue how the future will look like, but I do see that liquid fuels and gaseous fuels will play a role. I expect that, and we have to tackle then low carbon performance.
I must say I completely agree with you, Eric. Well done. So I think now it's time for a short break. I mean, we may take 10 minutes and be all back by 3 o'clock. No answer? Deal.
Yeah. Just a moment, Kristin or others. I have sent an email.
Right, it's 3 o'clock, so welcome back everyone. I hope you have taken a refreshing break, and now I would like to welcome Calliope Panoutsou from the Imperial College in London, who will cap this overview about renewable fuels with the most important aspect of policy needs in the future. Now, a few words about Dr. Panoutsou. She's a senior research fellow at Imperial College in the Center for Environmental Policy, and she's also the vice chair of the scientific board for the bio-based industries and chair of the working group on biomass availability and supply in the European Technology and Innovation Platform, Bioenergy. So recent work amongst an immense work over time has been related to integrated policy for biomass value chains and to industrial crops grown on arable and marginal land for the production of advanced biofuels. So, Poppy, we are all ears.
Hello, good afternoon. Thank you for being with us. I will just provide an overview of the policy work we are finalizing within the Advanced Fuel project, and talk a little bit about why we need to reconsider biomass policy and the policy needs we have identified so far within the project across the value chain stages of land use, biomass production, conversion, and end use. Why reconsider at this stage a policy which is more focused on biomass? Because so far biomass has been a contributor to single sector targets. The policy agenda so far has been based on delivering sector specific numbers for energy, for transport, for climate change, while the value chain approach, which includes sector integration, will allow to identify the challenges and the gaps along the value chain, will allow stakeholders to contribute for the stage of the value chain they can understand better. It will allow improving knowledge for geographical specific capacities and the context that applies to them, and it will improve the focus of the policy from the outset of the policy reform to target challenging elements like land use, like competition for feedstock, etc. Next slide, please. Why now? What is new? We are all aware European Green Deal is the new umbrella which brings together and aims to integrate most of the sectors, starting from the transition to a circular economy, zero pollution, farm to fork, sustainable transport, clean, resilient, reliable and affordable energy. So it is a very good timing for a biomass focus in policy, since biomass is a key component in most of these initiatives under the European Green Deal. Next slide, please. What is relevant for advanced biofuels? Just in brief, CAP post 2020 includes a specific objective among others that are relevant. The most relevant with advanced biofuels is the objective of contributing to climate change mitigation and adaptation, as well as sustainable energy. There's a clear layout of interventions, indicators, and these tie well with the Renewable Energy Directive 2 in aspects of cultivating unused, abandoned, or severely degraded land, and also including crops which benefit from improved agricultural practices. We've heard before from colleagues that presented that biomass feedstock is still the highest share of the cost, so broadening the feedstock and ensuring there's enough, it's secure and it's year-round is critical for the highly innovative technologies. Next slide, please. So our approach has been two-phased. We have a stakeholder engagement and analysis and modeling. They're going hand in hand. We have performed an analysis and direction where we understand how much biomass supply is there, what's the resource efficient conversion, the markets and the policy landscape, and then we tried to identify jointly with stakeholders and the project colleagues the policy aim, addressing challenges for market uptake, gaps in existing policies, and trying to draw a new biomass policy agenda. And finally, we tried to suggest a policy design with policies that are relevant, as well to resolve the gaps and the challenges. And we try to have an initial understanding of what their expected added value would be. Next slide, please. In the land use stage, there's the issue of marginal land. It's been addressed everywhere. Policies have ambitions for exploiting such land, but planning, financing, and awareness interventions are lacking. And also, there are misconceptions and low awareness in the farming community about cultivating lignocellulosic biomass crops. These require more targeted interventions for policy, regulation, financing, and also capacity building, as well as the issue of carbon, soil carbon and carbon sequestration. The benefits of biomass for these processes are still not adequately substantiated, so there needs to be clarity within the future policy. Next slide, please. For biomass production, we're talking, as Ayla mentioned before, we focus on lignocellulosic biomass within advanced biofuel, advanced fuel. So lignocellulosic crops may need new management techniques because they are new species. So there's a gap in knowledge, in the knowledge base among the farming community on the opportunities of these crops to be integrated to current agricultural systems, plus their practices that would be the most sustainable and better integrated within the local systems. So there are needs of training and education, and also the needs for refining farming and management techniques. Along that, some of these crops are still going under improvements for yields, for traits that have to do with water, heat tolerance, etc. So there is a need to increase innovation through R&D financing in lignocellulosic biomass cropping to make sure these crops can serve best the purpose they are asked to, which is to grow with low input practices in low quality land. The other issue is, again, I mentioned also for land use, the carbon sequestration. There are several ways to have resilience through carbon farming, conservation tillage, conservation agriculture, crop rotation, agroecology issues. These need to be addressed in detail and carefully through a common regulatory framework, and improved and standardized methodologies for data collection of soil carbon are still needed. And last but not least, lignocellulosic is not only about crops. We need to mobilize residual streams, and there seems to be an absence of dedicated policy support for mobilizing unmobilized biomass streams that are across fields. And so policies should refine the rules and the financing for specific residual biomass. Next slide, please. For conversion, you had a lot more details from my colleague Stavros, but we think that through the analysis we've been doing so far, that the fuel mix and an increase in energy efficiency are considered critical for the advanced fuels and RESfuels to meet the Paris Agreement targets. So the policy measures need to be strong enough to ensure the significant amounts of RESfuels and zero emission vehicles are deployed. And these need to go hand in hand with the energy efficiency improvements. There is low access to capital in SMEs and industries, especially now after the COVID-19, this is even worse. So improving access to finance and regulatory support for SMEs and industries to share the risks and facilitate decision-making is critical. And finally, technology development, because it's innovative, again, needs a combination of policies and support to make sure that innovative technologies will be commercialized on time to support the targets. Next slide, please. For end use, we have seen a slow uptake of advanced fuels and RESfuels because of their high costs. Tailored financial support, again, to reward efficiency and improve the market pricing is important. Also, non-financial incentives and information provision are needed to promote the new technologies for carbon efficiency and market regulation, together with the regulatory instruments such as feed-in premiums, certification, and standardization. Next slide, please. So, as I mentioned, we're finalizing the recommendations, and we are working along the lines of optimizing the targets for future policy across each value chain stage and for specific activities. So for land use, we're working on land acquisition and soil management issues. For biomass production, we are orienting our recommendations for crop establishment and annual management, pretreatment, storage, and transport. In the conversion side, we are working on recommendations for the construction, so the capital expenditure and also the operational issues throughout the lifetime of the plant, and for end use for the distribution and consumer use and perception. Our results will be available towards the end of August, by the end of the project, but we are very happy to discuss issues with any of you that has any comments or recommendations. Thank you very much.
Thank you, Poppy. That's a very interesting presentations, and I do have a question for you. Obviously, the Common Agricultural Policy and the European Green Deal, they are awesome instruments. Do you really think there is a chance today, this time, for biofuels to be considered, and thus show everyone the EU is ready to break these traditional silos between agriculture and energy, energy and industry, etc., etc.? What's your perception as someone who is very well connected to this environment?
I think it's there are excellent opportunities, and to my opinion, it is from the unique moments that we see different sectors forming policy that actually can interface. That's why I've shown the slide of Common Agricultural Policy post-2020 with the climate objective and the RED II synergies. So I think it's a very, very good moment, and also especially during the crisis, there's a common understanding that we need to improve resilience across the European economy and within the bottom up, within the local systems, within our borders as Europe. Circular economy and the Green Deal is an excellent opportunity to help agriculture go hand in hand with energy, and biomass is one of the key natural resources that can be produced locally and can be used within our territories, and at the same time not only deliver energy and fuels, but also help the rural areas stand on their feet, add complementary jobs, add income to their regions. So I think it is a very good moment. First of all, they speak the same language, as I mentioned, at least the two main policies, and also recently the carbon farming is within the biodiversity strategy, within the farm to fork. Of course, each comes with their own agenda, but they all understand the urgency, and biomass seems to be a common denominator within them at many places.
Indeed, thank you. But then we have a question from the floor.
Yes, we have a raised hand actually as well from Sophie Wegenbert. And Philippe, if you don't mind, I just demute her, and yeah, and then Sophie can ask her question. Hello.
Hello.
Hello. Can you hear me? Yeah? Okay.
Yes.
Since this, if we're using marginal land, I think that's a pretty good opportunity, because you avoid using land that is useful for food production. But how do you consider biodiversity? How do you take that into account? Because sometimes, yeah, you're also in a project, and the question that I've always okay, you're using marginal lands, but there's interesting fauna and flora on this land. So what do you do with biodiversity if you're planning to put crops, bioenergy crops on those lands? How can you manage that? So the question of biodiversity and production of bioenergy.
If I understood well, because it was kind of blurred, but if I understood well, you're asking how can somebody manage biodiversity with crops? I think, first of all, there's not one rule fits all. It's down to the ecosystem we're talking, and these are quite wide. But through crop rotations and agroforestry, through practices that are, first of all, suitable for the climate and the ecology of the region, there are opportunities to develop biomass and source the circular economy, the bioeconomy, and advanced biofuels. Of course, all these under the regulations that are at the moment in place. I hope I understood well, but I'm happy to respond also by email or talk more in detail. It was a little bit blurred.
Okay, no problem. But I think you understood it well.
Thank you.
So, yeah, thank you.
Okay, thank you, Poppy. Now we're going to move to the last two presentations of this webinar. And these two presentations are relative to pioneers. Actually, two Dutch companies having been founded by the same person, which is interesting, and investing in two sectors where the renewable fuels are indeed a key solution to reduce the carbon footprint. And of course, we're talking about marine and aviation. So first, we'll start with the shipping sector, where Goodfuels is making such an impressive contribution in the domain of marine biofuels. And then we're going to listen to Rianne de Vries. And Rianne is Manager of Business and Government for Goodfuels, with a background in consulting and alternative financing for sustainable and innovative projects or investments. Rianne joined Goodfuels 1.5 years ago, although I understand Goodfuels will miss Rianne for maternity leave from July to November. So all the best to you, Rianne, and too bad for Goodfuels for these few months. Rianne is also responsible for all running innovation projects and getting involved in new research and development projects, and also for policy and lobby activities. So Rianne, your call.
Thank you, Philippe, for that nice introduction. And thank you for all for joining this webinar, this workshop today. I'm very keen to share some information with all of you and to be invited to share this with you. So thank you for the organizers as well. Next slide, thank you. First off, I want to introduce Goodfuels, and hopefully after that, going to talk about the opportunity of marine biofuels, our fuel solution, our scaling up plans, the innovation projects we're currently in, and the focus that we have in those projects, as well as a bit of an outlook on what's next, really. But first, let me introduce Goodfuels. Next slide. Thank you. Goodfuels was founded in 2015, already 5 years ago, by Dirk Gronemeyer, who also founded SkyNRG, the company we're going to listen to in 15 minutes or so. SkyNRG was founded as a biokerosene for aviation company, where they would have the ambition to put as much biofuels in the aviation sector as possible. With KLM as one of the shareholders. I won't go into much detail there. But Dirk, after 5 years, decided that he would do the same for the maritime sector, where he would see big opportunities for biofuels as a solution towards the big CO2 issue that's currently rising in the in the shipping sector. It's an Amsterdam-based company. Currently, around 15 to 20 people work at Goodfuels, and we are aiming to bring as much biofuels or any other solution into the market to make transport fossil-free, to put it simple. We have a focus currently on heavy-duty transport sectors. We serve both the maritime sector and the road and rail sector. We do this in partnership. We co-develop biofuels, as well as we commercialize biofuels. So we do this in partnerships. We do not own any biorefineries or any other assets, but we have all the knowledge from the entire shipping sector. Let's talk about the shipping sector for now. What we do is we bring our knowledge to the table in regards to what does a biofuel need to look like, what are the parameters, what are the specifications, how does an OEM look at a certain type of biofuel? Is it okay for a ship owner to put a biofuel in a ship? We have that expertise because we have already put a biofuel replacement of heavy fuel oil onto the market in 2018, but I'll get to that a bit later. I work for the innovation team. The innovation team is a separate department, really, of Goodfuels, where we look into detail on the fuels development. We perform engine performance and emission performance testing. We look at how the market is evolving. We look at policy insights. We take the whole spectrum into account. I'll talk a bit about all the innovation projects we're in currently in a bit later on. What I haven't talked about yet is that we are also not only working hard to put biofuels into a ship, but we're also trying to encourage cargo owners to take note of our Good Shipping program. That's a program that makes sure that cargo owners are able to make use of biofuels in a different way. I'll talk about that a bit later as well. Could you go next? Next slide, please. What is very important for Goodfuels is that we operate by our sustainability principles, and which are formed by our sustainability board. Our sustainability board consists of 3 members: Barbara Bramble, Professor Martin Jünginger, and Patricia Olseweyer. They have sort of a veto right on the feedstocks and on the technologies that we're aiming for to use for biofuels and shipping. Please, next. Already told you a bit about that, about this program. The Good Shipping program empowers cargo owners to take immediate control and choose a fossil-free pathway to ship their goods. What it means is that IKEA, for instance, can ship all their furniture from Asia, for instance, to the Netherlands via biofuels, by paying for the extra premium on top of the fossil parity price. This is a system that's been working quite well for the last 2 years, and it's been growing and growing. And we see this as a perfect way for cargo owners to take responsibility and to reduce their CO2 considerably. Next slide, please. First off, before I'm going to talk to you about the products that we offer, some of these topics have already been talked about today, but we all know that shipping represents 2.5% of the global CO2 emissions, and that sustainable biofuels today are actually the only available option to decarbonize deep sea shipping considerably. So there are, of course, other options in the sense of more efficient sailing, but fuel is one of the biggest costs and the biggest pollutants in the shipping sector currently. And with biofuels, drop-in biofuels, we could potentially reduce up to 90% of the CO2 well to wake. That's already what we've been doing since 2018, really. We all know that existing marine engines, they are big engines and they use a lot of fuel. So it's also a sector that has a huge impact. And if we can change that sector, has a huge impact on the CO2 levels. Current lifetime of these ships are very long, and Eric has said it, and others of you have said it today as well. We are currently still having to deal with a lot of these ships for the coming 20 to 30 to maybe 40 years. And these ships, they do not have the option to, on a cost-effective basis, to change their engine or to go to another system. So drop-in fuels, biofuels, would, in our view, be one of the best solutions. Of course, we also look at other types of technologies, because we also believe that even though biofuels will be part of the mix for a very long time, other solutions will come to the table as well, and we are proponents of other technologies as well. Next slide, please. To go a bit into depth about what are the products that we are currently delivering, we started out with an HVO in 2015, which is a very high spec fuel, too good actually for a marine engine. And we moved on from that to actually create a biofuel oil as a replacement of heavy fuel oil. And together with Norden, we launched that in 2018. And since then, we've been co-creating and co-developing this fuel to actually optimize it and to ensure that it is completely matching all specs and all standards. But these volumes are rapidly selling out. Next slide, please. To scale our fuel, we work with different residual streams from a range of industries, food, biofuels, cosmetics, and other industrial processes. As you can see on the slide about our sustainability board, we have some strict criteria for this, so we don't work with anything just like that. We have really a good criteria set in place to ensure that we are top of the bill instead of working with the marginal feedstocks or etc. We already gained a lot of expertise, and we look forward to expand this in the coming years. Next slide, please. Next slide, please. Oh, sorry, there you are. And we believe that our oh, sorry. Could you go back one? My internet is a bit slow, I think. It requires, next please. It requires a lot of testing. Thank you. That's it. Yes. It requires a lot of testing, and but we believe that our biofuel oil that we currently have in place could serve as an ideal carrier or blending component for new marine biofuels. I'm going to go a bit quicker because I want to go into depth regarding our projects that we're currently in. As I said, we don't bet on a single pathway or a feedstock. We have the testing experience, and that's needed to qualify for marine applications. We use our expertise in all these kinds of projects. Please, next. And since January 2020, we also are operating as a dedicated bio bunker barge, which really helps in scaling up and helps us in further spreading our message, and has given us a lot of opportunities regarding to the blending of the fuels. Next, please. One of the most concrete projects we're currently working on is together with BTG. Together with BTG, we're working on setting up a plant for using fast pyrolysis oil. We see pyrolysis and in combination with woody residues as one of the biggest opportunities for biofuels for shipping. And we hope to get a commercial scale expected in 2027, 2028. So this is a project really to watch, and hopefully I can tell you more about it in a year or two. Next slide, please. As a strategy, as an innovation strategy, Goodfuels is part of a lot of European and Dutch-based grants projects. So Horizon 2020 and Dutch national grant programs. We're currently in 4 Horizon 2020 projects with a lot of experienced partners ranging from government to knowledge institutions and universities. As said, we don't focus on one technology, but we do have a preference, for instance, towards HCl. So HCl is something we see as a very beneficial and a very good technology that could deliver us the right fuel for the maritime sector. Next, please. Next to HCl, I already mentioned pyrolysis. In combination with sawdust, we're in this project called Music, where we are involved in the logistical part of the knowledge part. So we bring in our logistical knowledge. Next, please. 2 new projects, Ideal Fuel, and the next one will be Biosfera, are going to be focused on sulfolysis, and this one on sulfolysis and lignin. We have a role in this project where we look at the market outcomes, the market uptake, as well as we look at the blending recipe, and we look at the parameters of the fuel that hopefully comes out of this project very soon. So we have a very wide range of activities in these types of projects. And I think regarding the time, I'm going to skip all the Dutch projects. I think the most important message I want to give you regarding these projects is that we have a very diverse role. Either we are an application partner, we test the fuels, we look at the standards, we look at the specs, or we are on the other side of the spectrum where we look at the market uptake of a certain type of fuel. And we can do that because we have already brought onto the market a biofuel, and we know where the opportunities lie. So if you could go to the next slide, and then the next slide. And then you can skip the next 4. So next, please. Next, please. Yes, this one. What's next from here? We look forward to collaborating with different suppliers using different feedstock and technologies without compromising quality or sustainability, which is very important for us. We want to become the biggest supplier of sustainable biofuels for shipping sector, and we want to do that fast. We see a very nice market existing already, and we think there is even more to come. We do that sourcing residual products. We hope to have a lot of offtake of future plants. We participate in future plants like the BTG plants, and we co-create and commercialize biofuels. I hope, even though I put too much information in this presentation, that it was quite clear to you. And if not, then please contact me for any questions. Thank you for listening, and hope to meet in the future.
Thank you so much, Rianne. A very full presentation indeed.
Yeah, sorry.
Questions from the floor, Kristin?
Not as a raised hand, but there are a couple of questions in the question box. So if we have a bit of time, I would just read them out. What do you think, Philip? Or should we leave this for the discussion round?
Yeah, I think we have time for one question. Go ahead.
Okay, the first one was from Antonio Prada. In your opinion, will the different biofuels be available in volume and quality, and the cost would be competitive to be used as alternative to current marine fuels? In your studies, stability and compatibility aspects are considered?
Okay, I think the first bit of the question was regarding availability and price. We already see that for the product that we currently are commercializing, so our biofuel oil, that to really cover the whole shipping sector, that's not going to happen, and that's in our view also not necessary, because we believe in the different types of solutions that are currently developed. So all the biofuel solutions we are proponents of, but also the move towards more e-fuel types of fuels, or bio-LNG, for instance, as long as it's fossil free, as long as it's a sustainable option. We believe that that there is really enough to cover all ships, but it's quite challenging to completely decarbonize the complete maritime sector. I think we need a lot of everything so that we can create as much impact as possible. And I think it's a bit regarding the discussion that you previously had with Eric regarding a transition fuel. I'm not so much a fan of the word transition fuel, because that I hope that it doesn't stop investors from believing in HTL or pyrolysis, for instance, because we need to scale up, and we can't really wait for 20 years until a certain technology is ready, because that will take another 5 or 10 years to be commercially ready as well. Regarding cost, we see developments currently in these European projects that we're part of, that the cost is going down, and that it might be able to match even fossil prices. But we also know from the current crisis that fossil prices are moving up and down. So what really is the reference price is quite difficult to say. But I do believe that for maritime fuels, it's the easiest fuel to make, in the sense that it doesn't. You can put rubber in an engine that has a burning capacity, so it doesn't have to meet the highest specs as it has to in the road sector. So we do believe that with enough stimulants, with enough incentives, with enough R&D, that we can move towards a cost competitive price, and hopefully in the future we're competing against biofuels instead of competing against fossil fuels, which is quite difficult because the prices are so low. I hope that answers your question a bit.
Thank you, Rianne. I think we will save the other questions for the discussion part of the webinar, because there's a few questions that came up on the screen. But we need to move on, and so we have one final presentation before we go to the discussion part. And now we are dealing with the aviation sector, and we will give our full attention to Oskar Meijerink from SkyNRG. Oskar is the project lead in the Future Fuels team, and is involved in 8 regional sustainable aviation fuel supply chain projects, and with a specialization in CO2 to jet, Fischer Tropsch, pyrolysis pathways. Oskar studied energy science at Utrecht University, and specializing in sustainable aviation fuels, and also investments in sustainable aviation fuel supply chains at Imperial College London. So you can take off now, Oskar.
Perfect. So thanks a lot for that introduction, Philip. I hope everyone can hear me clearly. When I done general progress of the market and technologies. Some things are already mentioned before, Rianne, as mentioned. There are quite some similarities between Goodfuels and SkyNRGs, but I'll touch upon that when relevant. So in principle, at first, the aviation industry has basically three sort of big challenges, or we see these three big challenges. And the first is, well, I think a year ago or so, we would have said here that demand is increasingly growing. At the moment, it's obviously a bit of a crisis in the aviation sector. So the growth is somewhat sort of away from the charts, so to say, but at the same time, we will see that aviation will remain to exist, and society will more and more demand sustainability from that sector. You also see it in the discussions around savior packages for the airlines, that there's increasing in certain countries, there's increasing demand for sustainability requirements with those loans put out to the airlines. So there's quite an interesting pull on sustainability. At the same time, obviously, there's an increasing impact of the aviation industry on the entire world. At the moment, it's only, you could say, 2%, but if we don't do anything, it could end up very well being over 20%. And the third, which is probably most relevant for this presentation and for our company, is that the alternatives are quite limited. So the alternatives in road transport, where you could do electricity, and also marine or heavy trucking, which have a bit more alternatives in LNG or methanol maybe, or aviation, we don't see that development that quickly. So we will probably rely more on drop-in fuels for the years to come. So next slide, please. This is a slide most of you probably know. What it basically tells is that the industry is growing, or even if it's consistent, we have to do something about that growth, because the industry basically said, okay, in 2050, we want to reduce our emissions by 50% compared to 2005. And if we look at how to achieve that, then you can do a couple of things in terms of efficiency improvements on technology, operations, or infrastructure, but in the end, the real reduction needs to come from alternative fuels or radically new technologies. So next slide, please. And if we look at those alternative technologies, we see that there is quite some interesting potential for electrical aviation, even hydrogen. Hydrogen propulsion is quite some research going on, but at the same time, the aviation industry is quite slow in implementing that, especially regarding safety, of course. So what we see is that we expect to at least 2040, 2045 to remain to rely on the equipment we're having now and on the airplanes we're flying with today. So next slide, please. So that's what SkyNRG has been doing the past 10 years. So we've been founded in 2010, basically as a first goal to do the first commercial flight for KLM, which is the Royal Dutch Airline. And since then, we've pioneered the sustainable aviation fuel downstream supply chain. So on the short term, you see those activities that have been the main activities for the past 10 years. So what we do is we purchase fuel from a producer. We blend and make sure that those adhere to all the quality standards that exist, ASTM being one of them, and we arrange the inter-wing delivery of the fuel. So we take title of the fuel, we own the fuel, and we ship the fuel, we transport the fuel to wherever our clients want it. So what that means is we've pioneered the first segregated flights, for example, where there was a dedicated truck refueling one airplane, all the way to the current situation where we on a continuous basis supply Los Angeles airport into the fuel farm. So it goes commingled into the existing tank capacity and end up ends up basically in all the aircrafts on an airport. Two main elements in that is co-funding the premium, so similar as what Goodfuels just mentioned in terms of asking people in the supply chain or clients or stakeholders, large corporates, to pay a premium so that all the premium doesn't end up with only the airline. We also have a sustainability board ensuring the sustainability, of course, but more interestingly for us is our long-term focus. So we just recently announced last year that we are building our own production facility in the north of the Netherlands. It's what we call DSL1. This one is going to be based on the HEFA technology, so we're taking in waste oils and fats. No virgin oil is being used, and we focus that facility on sustainable aviation fuel. So basically on an aviation fuel focus and not a diesel focus. And that's quite different than the existing HEFA facilities out there, because from an economic point of view, it's easier and more economically feasible to go towards diesel. The second point on the long term is that we are involved in about 15 projects around the world where we look at new technologies in a collaborative setting, and we're now focusing on developing and executing new supply chain projects where we're looking at building additional capacity around the world. So next slide, please. I'll skip a little bit through this one, but it's basically saying we see the most activity in the United States and Europe, basically because of the supportive policies in these regions. So both in the US as well as in Europe, you're now allowed to, at least in some countries in Europe, you're allowed to blend in sustainable aviation fuel as a voluntary opt-in, so to say. So it's not mandated, but you can count towards the same target. And this helps to develop the market because it partially co-funds the premium. Next slide, please. But in the end, it's all the same. So what we look at as a soft supply chain is basically first the feedstocks. This is for European setting, right? So first the feedstock needs to fit with the Renewable Energy Directive. It needs to be sustainable, and it needs to be complying with the Annex 9 as we know it, so A or B and or B. The second is for setting up a new supply chain is, okay, is the technology ready enough to invest in and create a commercial facility upon that technology. The final piece is the ASTM certification. Is it allowed to be used in commercial aviation? So that's the essential necessity to build a supply chain or to build a facility for that sake. But to reach the real impact and to be able to build larger scale facilities, you also need those bottom two things, and that's the feedstock availability and the price competitiveness of your end product. So next slide, please. So what we've basically done, and that disclaimer on the right hand side is quite important. This is not a factual based assessment. It's not a university kind of assessment, but it is the SkyNRG point of view at the moment, where we looked at all the or most of the technology, feedstock technology combinations out there. So what we've done is we've scored them on a very simple scoring metrics from a green sort of tick towards a red cross. So don't be upset when there's a red cross behind your technology, if any technology players are out there. But it's an assessment to see, okay, which pathways are out there and what can we learn from that. And if we can go one slide further, we probably end up having a conclusion based on this. Yes, so the first conclusion that we've drawn from this assessment is that we see that the technologies with the good technology readiness level, for example, the HEFA case on top there, or co-processing or even renewable diesel, those have a less good or a poor fit with feedstock availability. That's obviously the whole case of, for example, using used cooking oil or using virgin veg oils, which might compromise the Renewable Energy Directive, which don't completely meet in targets. So that's a bit of an issue with the Renewable Energy Directive. If we go to the second conclusion, we also see that the Part A feedstocks in the Annex 9 of the Renewable Energy Directive, so those are the ones with a lot of feedstock availability, like municipal solid waste or cellulosic material, for example. Those often do not have commercially ready technologies to convert those towards jet fuel. And this is specifically for jet fuel, right? So, for example, if you go towards heavy fuel oils, this can be completely different, but this is focused on jet fuel. So when there's now a technology push or a feedstock push from the Renewable Energy Directive for advanced feedstocks, we also see that there's not really a technology ready to convert those feedstocks into jet fuel. And the third conclusion here is that, so please next slide, that we see an increasing opportunity and also an increasing amount of hope being placed on the synthetic pathway or the Power-to-X pathway. 2 years ago, we've not heard a lot about that, and since then there's been a lot of attention, and we've done a lot of projects on that pathway as well, where we looked at the possibilities of taking CO2 towards jet fuel, and it's very interesting, but there needs to be quite a bit of work to be done to reach that, and even more so, there needs to be a lot of renewable electricity before that becomes a very interesting pathway. Nonetheless, we need to put a lot of effort in that pathway because there's no scenario without that pathway playing a large role. So that all being said, I think the conclusion is that we need to look closely to the Renewable Energy Directive and how that stimulates the various technologies, but also look at alternative methods to stimulate those technologies that might not yet be there, but where we do see the feedstock opportunity. So if we can go to the next slide, please. Close my presentation. One final slide is we see quite a bit of change in the policy dynamics from it being very voluntary, so the Renewable Energy Directive and also the LCFS in the United States or California all being voluntary opt-ins for aviation, now being transposed into mandated systems where Norway already mandated 0.5% this year of sustainable aviation fuel in the mix, and a lot of the Western European countries following that example, adding up to about 2 million tons in 2030. So if that takes place and we see that becoming more and more interesting, also from a European Green Deal perspective, that's going to be a huge change to the market dynamics in this space. So I think I'll conclude it there. One last slide. So if there's any interest in participating in any of our projects or being involved, please let us know.
Thank you so much, Oskar. Is there any question from the attendance?
I don't think so.
Okay, then I'm going to still ask one question to Oskar. We know that the president.
Sorry, I missed one. Sorry, Philippe. There's Yuri Koyan who would like to ask the question. Yuri, you are demuted now. Go ahead.
Yes, first of all, thank you, Oskar, for excellent presentation. Kristin, would you be so kind to come back to the slide with the feedstock technology and technology readiness level policies? This is really good table. I really like it. And I have one question about this, actually the synthetic kerosene from CO2. As we've seen, for example, from LanzaTech, they have some technology readiness level. You think it is still low to go forward?
Well, I think if you look at the LanzaTech process, they take a waste gas from steel mills, in principle, to make ethanol, and then you can do ethanol to jet. So that first piece is now demonstrated on sort of a demonstration scale, and they're working on scaling that up. So the ethanol production is quite interesting, but it's not yet proven on sort of a large demo or pre-commercial scale. So we need to take one step there, I think. We work a lot with LanzaTech, we know them very well. And then the second piece is the ethanol to jet piece, which is relatively easy, I would say, technology-wise. But we also need to see that, and we need to make sure that someone can provide a license with sort of the guarantees of production before you can create an investable business case on that, right? So that's indeed close. So I would say that pathway based on a syngas towards ethanol and then ethanol to jet is sort of a yellow tick, I would say. In general, the CO2 to jet case needs quite a bit of work, both from a smaller scale Fischer-Tropsch. Fischer-Tropsch works very well on the large scale, but smaller scale Fischer-Tropsch needs some work, and especially the electrolyzer part to make the hydrogen needs some scale up as well. And then the question is, where do you get your CO2 from? Is it a biogenic CO2 source? Is the point source from unavoidable emissions? And what are the CO2 or the sustainability consequences of using such a source? Or are we waiting on direct air capture? Or is there a transition phase in terms of first using a biogenic point source, moving towards direct air capture when that makes sense? I hope that answers the question a little bit.
Yeah, so in general, the path from CO2 to ethanol is a little bit lower in the technology readiness level than ATG. Straight.
Yes, I think they both need a sort of a pre-commercial commercial proof point. Okay. But I think that's the closest to market after HEFA, to be honest.
All right. Thank you very much, Oskar.
No worries.
Okay, we'll keep the next questions for the discussion part. Now, I think we've closed the part about presentations. Of course, if this webinar would be in person, I would ask for a round of applause for our presenters, but it's not possible. So I hope you all will send a thank you note to Kristin and everyone having been involved in the Advance Fuel project for their impressive contribution to the subject of renewable fuels. Hopefully you will do so if you have enjoyed the presentations. And for now, we're going to start the discussion part of this webinar, and I leave the floor to Ingvar as your moderator.
Yeah, well, at first I would like to thank you, Philippe. You have been a perfect chair. Thanks a lot. Even though your camera wasn't functioning, that was a pity. But I think it's still went smoothly, and so we are at our last point, the discussion session with you, with our audience. So we are looking really forward to get engaged with you, to hear your opinion about what you have just heard. And for this, I'm quite happy to introduce you to Ingvar, who will be the moderator of the discussion session. And just a few words towards Ingvar. He's actually also in our advisory board, as I already mentioned before, and has lots of experience. Since he has more than 45 years of experience in the process development and design and engineering in the gasification-based technology sector and also in the energy sector in general. For 15 years, he was Chief Technology Officer at Chemerex, primarily involved in projects that focused on producing renewable fuels. And for 5 years, he also worked as Senior Project Manager at Aalto University of Technology. And furthermore, he has built up the European technology platform, now with the European Biofuels Technology and Innovation Platform, ETIP, which he shared from 2016 till 2018. So he has lots of experience also to share with us, and he has taken the task of moderating the upcoming discussion round. So Ingmar, the floor is yours.
There, unmuted. So hopefully you can hear me. Thank you so much for the introduction. Maybe too much in a way. I mean, if you been around for a while, you have of course a lot of experience. So hopefully it's of value at this time. I have taken down questions which has been written in the question box, and I have also composed a couple of my own, or kind of not so strange in a way, because some issues easily come up when you hear all these good presentations, and I will lead you through this these questions, and the people on the panel, the various speakers, they have basically to pick up and answer. I will say who actually these questions have been addressed to, but I'm sure that there will be others who would like to maybe give input to certain of these issues. So it's not natural that, for example, Ayla want to answer all questions relating to her topic, because there can be others who have an interesting view on her very good presentation. So the first question, which is then directed to Ayla at TNO, is you said in the beginning that the greenhouse gas emissions only was taken tank to wheel, but then I think that the modeling you presented actually was well to wheel relating. I may be wrong there, but I ask you to clarify that.
Yeah, I mean, within the calculations, the cost optimization calculations, indeed, we are looking at from biomass supply to transportation to conversion, distribution, and end use. All the factors are included in the cost optimization model. Whereas when we introduce this greenhouse gas emission reduction target, we just simply assume that this will happen in the tank to wheel. So in the greenhouse gas emissions, we did not calculate the life cycle greenhouse gas emissions, which is going to be done. Only within this study, we haven't done it. So there will be another work coming where, based on these scenarios, what will be the life cycle greenhouse gas emissions, it will be conducted.
Okay, very clear. So another issue is that the question is like this: why do we need a combination of policies? Of policies? Is a quota obligation for the different end-use markets not enough?
Yeah.
And if not, and so on. You can start with that. Yeah.
Yeah, a very good and a very valid question. I mean, one of the experiences with the quota obligation, also the style of the policy measure, is that they are suitable more for the technologies that are mature, that can compete in the market. And with the quota obligation, you can get a ticket, a price level that can push, for instance, technologies that are close to the commercialization as well. But when we talk about more advanced technologies, for instance, for the aviation sector, we are talking about Fischer-Tropsch, for instance, quota obligation in itself may not be sufficient enough. And I mean, a combination of the two can at the same time provide a production subsidy for a period of time until the technology becomes really commercial, reliable, let's put it that way. And at the same time, you can combine it with a quota obligation whenever the fossil fuel prices drops extremely, for instance, you can just close the gap. Am I being clear here? I'm not sure. But I mean, one configuration is I will just give a simple example. Assume that we have a quota obligation, and then it pushes feedstocks or biofuels like HVO to some degree, first generation biofuels, and then bio LNG. It may push to some degree, and co-processing of pyrolysis oil. But when we want to move further, which our model shows that they need to be in place on time, then they will have quite some difficulty. And then we were talking about the additional gap actually that can be covered via feed-in premium until, as I said, the technology becomes more commercial. And I think this topic is quite open for discussion, and I would like to hear opinions from other people as well.
Yeah, is there anyone else who would like to add comments to this? Oskar?
Yeah, this is exactly the point of the slide I was sharing, right? So when you have a quota, for example, or an obligation for aviation fuel at this moment in time, this will probably be filled with HEFA fuels. If we want to push other technologies that don't have that technology readiness level yet and are therefore more expensive, you need to create some sort of system or some sort of feed-in tariff indeed to bridge that additional premium. You see that very clearly now with the more advanced biofuels, for example, but you also see that coming up for the synthetic-based projects, where at the moment you just need to build a couple of pilots and then a demonstration facility, and then when that's proven, you can start scaling that up. So, and there's multiple ways of doing that, right? So a feed-in tariff or a sub quota or whatever, but that's, yeah, all has its pros and cons, I would say.
I think we can say that this is a topic on its own. Maybe Eric, you can add something.
Yeah, what we as a platform suggested last October in a meeting here in the Netherlands, sorry, is a bit different because in the end, what the problem with the quotum is that it sets the pace of the introduction of renewable fuels or renewable energy or efficiency in a sense. And beyond that percentage, nothing will happen because there is no policy. You could say there is a kind of a policy and a price desert. So the trajectory in which we now start moving towards higher shares of renewables is actually dictated by this quota percentage. And it's surprising that in a way we leave, let's say, the fossil fuel and the fossil energy totally untouched. So if I was a fossil fuel provider and I would be, let's say, confronted with an increased share of renewable fuels that would actually eat in my volume, I would seek ways to secure my volume. Percentage-wise, it could perhaps drop to this percentage level of renewable energy, but I would make sure that on volume-wise, I would still expand. So I would expand the total energy needs and mobility needs, or make my prices a bit lower to secure my volumes. So what we argue here is say, listen, in the absence of a more fixed target and a lowering limit of fossil, it will be very difficult to actually enhance the development and innovation in renewable energy. So we said, suppose in 2030, in the Netherlands, you can say EU, we would only allow 2/3 of the current level of fossil in the energy system for mobility as a way to go to zero by 2050, then we know that the mobility needs will certainly be larger than that and need to be fulfilled by renewable fuels, renewable electricity, or efficiency gains, and that would spur innovation, and it would actually boost the development of, let's say, lower TRL technologies, because we know that, let's say, this is where the growth area will be. Even if in 2040 it would be, let's say, 1/3, even half of the volume in 2030, you would know there is only one way where we will grow. It's in the renewable energy era. And that will then, let's say, direct all innovation and investment capacities to the renewable fuels and renewable electricity. They would then collaborate, or because it makes clear that fossil in a way ends. It is an end game. It will last for 30 years, but it will end. And by converting it, by setting actually pressure on the fossil amounts, it would, let's say, really, how you say that? It would loosen, it would release all our innovation capacity in that level. I think that would be making much more sense than, let's say, dictating at a very slow pace this renewable energy target.
Eric, you can hear this. This is a tricky area, and Eric has done a lot on this, and a couple of us have spent a lot of time. There is an interesting, I think we need to finish this first chapter or the first paper, even though Ayla would like to say something more maybe. But I urge you to look into the new paper from the Commission about CFD possibility. I mean, a new financing structure, contract for difference is called, which is quite interesting, and it's one way to open up this discussion. But I think this is something for the project management here to see as a very important development of the advanced fuel concept. Maybe the financing issue is a real issue, as you can hear Eric. So let's go to the second paper, and I just checked my questions a little here. Yeah, I wrote one of those questions myself, and I said, why is there, this is sent to Chalmers, to Stavros, why is there a higher learning potential for methane in the long term than compared to methanol, for example? It was one of your slides, number 27 in the long line. Maybe you can put that picture on, Karina. Or meanwhile, Stavros, when you got these lines for various technologies, I was a little surprised about the slope of the curves.
Can you go back to this?
Yeah, no? I asked the secretariat to put in slide number 27. I think I can see here. That was I got all the presentations in one long row. You see, that's the reason I can. It's the one where you show. Yeah, that's the one. Sorry, great. So methane production have a better slope than, for example, methanol, and I think the production routes are very, very similar. So how come that you actually have made them different slopes?
It has a slightly, yeah, you're talking about the comparison between, let's say, the green line and the orange line, right?
Yeah, yeah.
Yes. I would, of course, because this is quite a complicated calculation, I would have to go back to all the numbers that they also have to do with what is the cumulative annual growth expected for the fuel, because this model does not depend only on the learning potential on the technical level of every component of the technology, but also depends on how much is the capacity you expect at the end.
Okay.
So here in this slide, the capacity is not shown.
Okay.
So this is the number of euro per kilowatt product, but it can be that in the projection to 2050, the expected use of liquefied biogas is more than methanol. And that's why has by increasing
because my point in this
more
is
units, more plants, and this.
Yeah, I understand that more capacity, more learning, more plants constructed. My other question belongs. Sorry.
Yeah, and I mean, if I could go back to the numbers, I could verify this if indeed this is because of the capacity, but I suspect it is.
Yeah, great. Now, because I have a kind of a second question on the same theme here, that if you go into gasification-based technologies like making methane or methanol or FT, I mean, the downstream processes used there are really, let's say, already mature. I mean, they have been there around in the world based on coal and gas and oil and so on. It's really only the feedstock handling and gasification itself, and maybe some step directly after gasification, which is new technology, and where you can see a real development. While the other ones are
that's
mature.
True. If I could show up the I don't have it here with me, but if I could show up the whole table of the learning parameters that were assigned to this model, you're right. All these technologies were assigned to the lowest level of learning. The only technology, the only process component that was assigned to a little higher learning rate was the gasifier itself. Perhaps together with the syngas cleaning, but mainly it's the gasifier itself. So you're right about this. So it's not,
okay,
it doesn't have to do with a process, specific process component that are expected other than the gasifier, perhaps, that they're expected to have a very huge learning rate. Of course, then there is the question in this kind of models, if there is a learning rate after a certain capacity, or perhaps in the model you could set the learning rate down to 0.
Yeah, right. Okay,
and in this case,
Stavros, is this available for you to present to the program? Is the background material here available?
It is going to be soon public because it is in a report in a deliverable of a project.
Okay.
So it's going to it's a report that has all the learning parameters used.
Okay.
But I remember also by it that but the gasifier step was the higher learning potential. However, we had a minimum amount of learning in every kind of technology. So this is perhaps something that one could look again, perhaps by looking in oil refineries. Do oil refineries have learning rates after 40 years in commercial technologies? We haven't looked so deep into this comparison.
Oh, but this is, I know that in this IEA bioenergy report, which you refer to, we did this similar activity, and so we got to, I mean, the curves looks quite similar, and I put the same questions then, you know, is this really realistic? Just because you repeat, let's say, mature technology, and we have to be careful so we don't overemphasize the learning curve possibility.
Of course, and I would like to add something here that perhaps the take-home message is that you can expect some cost reduction, but perhaps saying this comes with a price of thinking that you're going to have 1,000 plants installed or gigawatts of capacities. So it's not going to come with just installing 5 or 6 more plants to reduce the capital cost in half, and even 40% may be ambitious in capital cost reductions. So it's more like a theoretical limit, perhaps, that you can. I think this is the take-home message by this.
Thank you so much, Stavros. We need to move on to Michal's. Do you say Michal's? Michal's paper. So I think it's good if you who are not talking or have muted your microphones, because if there are too many microphones on, we have some problems to hear. So, but now I like to unmute Michal. and
yes, I'm over here. So.
And I will give you a question here. Let's see now. Have you actually, in your work, given reflections on, in the real, let's say, mature situation of changing from fossil to renewable, where does the real capital charges come up, and where are the big costs? Are they in production of the fuel? Are they in infrastructure? Or are they in the vehicle adaptation? Because you said quite a lot about that we should be in the infrastructure, which gives a signal that it's really the infrastructure which is the expensive part. But is that really correct? What is your view there?
Very, very good point over here. So from my perspective, so you're right, like infrastructure, I think is one important, let's say, aspect we should consider when, let's say, taking into account new fuel. But I would say more, looking in the whole value chain. So I would expect the biggest obstacle, let's say, on the production side. So if we analyze those fuels, so one thing from the end use perspective, so we should have the good enough quality. So that's one thing. Or if we are thinking about drop-in fuel, so then we can blend it or use it in the same infrastructure we have nowadays. Then if we have, let's say, lower quality fuels, so then we need to invest in the infrastructure and also maybe in the vehicle, let's say, adaptation, also engine technology. On the other hand, the quantity of the advanced biofuels, so I think that's also quite significant obstacle over here, because anyway the production costs, as we have seen during the presentations of Stavros, we have still this gap between the fossil fuels and advanced biofuels. So from my perspective, because I'm, let's say, mostly focusing on the end use side and engine technology, so engine adaptation, I think it's not, let's say, so big issue. So it can be done. So of course some research and development is needed, but let's say looking at the examples of the ethanol, for example, in light duty vehicles, or let's say methanol in the shipping industry. So we have ready solutions already, let's say, in place. And of course we need the new builds which will enter the current fleet. So that's kind of the cost we should take into account. But then I think the bigger obstacle is related to the infrastructure. So that's why many fuel producers are looking into alternative drop-in fuels. So that's, let's say, first priority, because all modifications are then we need to think about the legislation, then the safety issues, and then storage handling. So then I would say the engine, let's say, when we look in this pyramid, so I think the engine technology, it's maybe not the biggest obstacle. We should consider the infrastructure, but I think let's say the biggest, let's say, challenge is at the moment in the volumes of those advanced biofuels, as we really cannot see the big volumes in the market and related prices as well. So that's how the situation.
I think I can even challenge the panel here and say that if you started to calculate these three elements and use the investment costs of plants, which, for example, Stavros presented in euros per kilowatt of production capacity, and do it for Finland or Belgium or Holland or whatever, and see how much capital you would invest to actually get so and so many petajoules of production capacity, and then compare that with investment in infrastructure and vehicles, I'm convinced that the cost of the production is by far dominating. It's by far the big cost. It's not infrastructure, and even so, maybe Ayla.
Yeah, we tried to make such a comparison actually, which we will also publish. As I said, it's a cost optimization that we are looking at, and we are looking at the total system costs, which not only includes feedstocks or conversion costs, but we, to some degree, try to include infrastructure costs and needed adaptations for the vehicles. We included this in the model. We can, of course, always discuss how good and not good the input data is, but the results clearly shows that conversion technologies, the cost of the conversion technologies are the major cost category for biofuels, followed by feedstock cost, and to our surprise, even the transportation of feedstock costs. When you go for very high levels, you need to transport feedstock not only within Europe, but also you start importing from outside. So transportation costs also become quite an important factor, whereas infrastructure plus the engine adaptations are comparably very small. So however, still the question is, if they are that small, why it doesn't happen? This is the chicken and the egg problem we all the time discuss. For instance, in our model, bio-DME is one of the preferred options for the heavy-duty vehicles. And according to the scientists, the adaptations needed for the vehicle is not that high and that expensive. But we do not see the move towards that type of a biofuel.
No, I think we park this question because this is something for the project to really put his hand on, because I think we have seen this. I mean, saying I've been working the biofuel technology platform for a decade, and I've seen this kind of discussion all the time, that we have a tendency to bring up the infrastructure as a kind of a governing thing, and it kills a lot of the good discussions, because the investments are not in the infrastructure. So I think this is very, very important to put up as a comparison. Very good that you've done it, Ayla, and I look forward to read about that. Yeah. Okay, it's 5 to end of the conference, and we should have some more papers here. So just jump a little to another question on I may get back to you, Michal, if we have time, but I would like to go to Eric and have this question about that there is quite a lot of activities going on within the shipping construction industry, the engine developers like Amman Turbine Diesel and Wärtsilä, and actually looking at alternative fuels. And as you know, there are also examples of how they're converted ships to, for example, to methanol. Methanex has done so, they have done so in Sweden and elsewhere. Do you think that there is a trend shift here? Is it really something coming up? There is a Danish decision just taken, as maybe you know about, the world's largest ship owner actually has put some strong signals. Microphone, Eric.
It is on, right?
Yeah, that's great.
Yeah, okay. Sorry, it was muted. Yeah, I think indeed that many people do see the opportunity of the methanol case, but I think some, if I take a look at the Dutch case, for instance, some also are a bit, let's say, cautious, because we had, for instance, this LNG case as well, where a lot of people thought, okay, if I'm going to make these investments on my ship with the engines and the adaptations, will there be, and that is the point, of course, where, let's say, infrastructure comes in place, will there be sufficient supply points for my new fuel? And I think that is an important one. If people operate in an international setting, then I mean, having one ship with, let's say, with a kind of a fixed port connection where it always comes back and it bunkers its fuel, then it's more easy. But when you want to scale up into a system where, let's say, these ships are flexible and independent from where they actually fuel their base, then it becomes more difficult. And that's where, of course, where it's insecure whether your investment and your capex investment in adaptations will actually bring benefits. And the benefit of, let's say, drop-in fuels at least is, if you can't find it at a certain point where you would need it, you can always rely on your conventional fossil fuels in a specific form. So this is something where actually I think the European collaboration effort needs to be in place to, I think an individual ship you can actually build, but it only becomes relevant and it gets mass, and it gets critical mass when indeed it is really helps in a kind of an overall plan to make it available at several spots at the same time. Because some are afraid that if they are initially investing in one specific engine, it might not work out to be the final solution in the end. And because of that fear for future missing out, so to speak, they are cautious to actually step in a specific field. Though I do think that a lot of people now have a very positive attitude towards the methanol option, but still we don't, except for these individual examples, we don't see it happening on a larger scale.
Okay, thanks. I will go over to after the break when we listen to Poppy and about the feedstock issue. And there was one question coming up. I'm not quite sure how to understand it fully, but I read it out as it was written, and maybe the person who has put the question can develop it further. Are there compatibility, safety, and handling and use aspects being considered in studies of various fuels? That is really the question. I mean, the whole chain of different aspects of how to handle various biofuels. Are you there, Poppy? Somewhere?
Yeah, yes, I am. I couldn't appear on the screen because there's an amount of people you can have with online screen. Yes, I understood that there was a question on the feedstock and then on the handling.
Yeah.
We consider including it in the recommendations as it is, because it is first of all, the feedstock handling, when you have to rely on multiple feedstocks, is an issue that has to be taken into account. But also, as you go to fuel handling, is also safety issues on transportation. So it's both ways. But first of all, in current, I'm sure everybody can confirm that, but currently biofuels are being handled under safety regulations for fuels, so they have the fuels directed behind them. So far, feedstock that has been used follows the norms of standardization as they appear with the CEN. But there are clear protocols. But as you broaden the feedstock and you go on residuals, on handling, on bulk things, yes, these things need to be taken into account.
I have another question which I have come up from my mind, and that is that there is quite often a situation that you, as a kind of a knowledgeable person on biomass availability and what can be done and so on all over the world, and especially in Europe, that there is that you kind of need to have a complete answer ready to a total change from fossil system today to a renewable system tomorrow before we actually can start. And I have the approach or the thinking that if you would have the right framework around this, you could really start, and there wouldn't be a problem in the first 5-10 years, because there is plentiful of biomass available all around. But because of this kind of limiting question, how much do we have problems to start. And I even believe that if we actually would start, there will be a lot of new sources which we really don't have thought so much about before, because people are innovative when you actually get started. But we have a tendency to just sit there and wait for the real push. Is that something you can comment on?
Yeah, first of all, I couldn't agree more with you than that. How much do we have available? Because we have available and we can create more. And actually, Scandinavia is one of the areas in the world that can prove it, because renewing the feedstock is done in a sustainable manner. We need to start, and we need to start yesterday. There are ways of producing and broadening the feedstock. There are issues of regulation, agroecology, as I mentioned, different management practices. It's not one fits all, but each region has its own resources. And with region, you can take inner regions within a country, you can take macro regions, which have groups of countries with similar climate and ecology, so they face similar issues. But definitely, we have the need to start urgently to broaden our feedstock use, start with the residuals, the waste, and start growing where where we can do it, and in an appropriate manner, not really distorting current markets, working synergetically with them, and also exploiting pockets of land that are not used at the moment for certain reasons, to the extent possible, of course. It was mentioned in the beginning by Philip and Ayla, there's also the issue of algae and marine aquatic biomass. Advanced Fuel has focused on lignocellulosic. There are many other options.
Thanks, Poppy. Thank you. Yeah. Now you have a new challenge here, really, to take on board, to move, to help us to actually get started, because you have really the knowledge on the feedstock side. Thank you so much. We're going to move on to the marine fuel and Rainy. Is that the right way to express your name, Rainy? Are you also? Do you have? Can you come back on the camera? Yeah, there you are. How do you pronounce your first name? With the microphone on. That's better.
Sorry. In Dutch, you would say Rianne, which has a strong focus on the R, but it's difficult to pronounce. So I always say that it resembles the name of Rihanna, but I don't sing.
Okay, Rihanna. I call you Rihanna. That's nice.
Good.
There was one question here. That is, you mentioned lignin as a feedstock material. I mean, for me, that's an intermediate, so to say. So how do you get hold of lignin as a feedstock?
We mostly look at woody residues in that sense, if we talk about lignin. That's one of the main priorities for us as a feedstock, that we see a lot of we have strong hopes that that's going to help us in scaling up biofuels for shipping.
Yeah, but where do you get the lignin from? From which process?
Where? Okay. From which process? Well, mostly for instance, with the BTG project that we're currently working on, that's sawdust as a lignin source. So sawdust comes from for instance, the process for chopping the large logs into pieces for the furniture industry, and all the sawdust that is left that we can through pyrolysis technology get a bio-crude pyrolysis oil out of. And the specific focus of this project is then looking into upgrading this pyrolysis oil to make it a feasible marine fuel.
But then what you really say is that you go from the raw material like sawdust, but not really to lignin, but directly to pyrolysis oil. Because lignin and sawdust is not the same thing. I mean.
No, that's true. That's you're absolutely right. But that's what I'm saying. Yes, we go straight from the sawdust into a pyrolysis plant, into a upgrading facility, hopefully.
Yeah, fine. Another question which has come up here from the audience, I think it is. So what is currently the feedstocks and pathways that are used to produce biofuel? Or maybe you already answered that in a way. Or actually today, what is your source of your fuel today? Is that pyrolysis oil, or is that other ways?
Not yet, unfortunately. It's still not on a commercial scale available, and we're still on a certain TRL level that we still need some developments, of course. But the current fuel, we started out with HVO. HVO is used cooking oil based fuel, hydrotreated vegetable oil. That's obviously a very high quality, high spec fuel, which comes at a cost. So it's very expensive, and the marine fuels currently are very inexpensive. So that was quite a difficult sell to make. So we in that process we have developed a bio HFO, a replacement of heavy fuel oil, and we have used cooking oil as a base. We've added some waste residue streams to that to create a biofuel oil. So it's a combination of used cooking oil and certain types of waste streams.
Okay, good. Thank you so much. Then I will finally go to Oskar here with one or two questions which has come up. One question is kind of to both of you, but let's go to SkyNRG for this. How do you avoid potential fraud in feedstocks and ensure the true sustainability of the original feedstock you use?
That's a very good question, and obviously a relevant question with the issues that we've seen in the past with biodiesel and with some of the used cooking oil pathways. Our safeguard system is probably quite similar as Goodfuels, is that we first, before even diving into a project or a pathway, we discuss that with the sustainability board, and what they basically do is we run through a couple of items with them. So they basically assure, or that we basically discuss with them, okay, how is it, where does it come from, how is it transported, but also more importantly, and that's always a bit more difficult to guarantee, of course, is to see, okay, what effects do you have by taking this feedstock from a market, and what's the effect in potential other markets that use that feedstock. So sort of the indirect placement effects or indirect land use change, but also indirect displacement effects can also be with woody biomass, with any biomass, or with any feedstock that could happen. So you have to be careful on that. So that's one element. So they have to approve, eventually approve what we are doing. So if they give a negative advice, we basically cannot go onwards with that pathway. Second thing is obviously we try to have, for example, RSB or ISTC or an EFD, the other certification schemes in place to adhere to the sustainability requirements set by the government or by policy schemes. That's just one part of it. And then the final point is sort of on the social side of sustainability. So that's more on, okay, do the people in the entire supply chain get the right wages, and is that all from a social perspective sustainable as well?
Has it happened that either in the marine business or in the aviation that you do C14 tests to see that the molecules you put in actually have a renewable origin, or you check the chain in the...
That mostly happens at the beginning. So okay, when you approve a new pathway, for example, Fischer-Tropsch, that's quite a recent discussion. There's a discussion whether you can, for example, co-feed biomass in, let's say, a gasification unit, and then allocate all that biomass to one of your products. So let's say you allocate everything to your jet fuel, for example.
Okay.
Which could be an interesting way of creating the first volumes and creating that market, but at the same time, in reality, those seed molecules end up everywhere, right? So probably a better way, or a more transparent way, so to say, is basically say if it's 5% co-feeding, you have 5% sustainable material in all your products. But then again, that also doesn't work for example, co-feeding vegetable oil in a plant, because those are very long chains. So those often end up in your very heavy fractions. Right. So therefore, you want to do some C14 accounting to see, okay, when you do a batch production, test where it ends up, and then take that for the lifetime, or for that specific type of feedstock and process you're using, take that distribution.
Thank you, Oskar. I had a question on my own here, but partly it was answered by you in the before the Q&A section. These very good matrix you have done, where you have your conclusion 1, 2, and 3. So I had this issue, say, what is your favorite? Because you have done all this work with all the crosses and the boxes. Do you dare to say what you think is most probable pathway? Is that possible to say, or is it just too far away?
The not so nice answer is that there is no perfect one. So
no, we can see that.
Basically, all have their downsides. Obviously, the first facility we are building is based on waste oil plus HEFA, so basically the second pathway. We believe that that first plant, we made them quite small. So for example, Neste in the Netherlands is doing 1 million tons in the Netherlands, and also 1 or 2 million tons in Singapore. So very big plants. We've chosen to do a bit more pre-treatment that we can take in dirtier types of oils and fats, and a lot smaller, so that we can take in smaller volumes, so only 150,000 tons in. We believe that on that scale, we could make that work. We can make that work, but maybe we can do another one somewhere in the world, but probably the next one's going to be a different technology, right? So, and then it's the question, okay, what is proven well enough? Could be, I think Fischer-Tropsch with biomass is difficult because of the issues of having a very clean syngas, or needing a very clean syngas before you can do Fischer-Tropsch. But maybe someone proves it, right? So Red Rock and are doing exactly this. So it will be interesting to see how they develop. Alcohol to jet is probably the next one up in terms of closest to commercialization. And then there is eventually synthetic fuels. Obviously, that's also what I've been working on for the past 2 years. So if you ask me personally, I would say that's the most interesting one for the long term. But that's not that doesn't mean that that's investable right now, right, on a commercial scale. No. And then there's the other ones like pyrolysis and HDL and what BTG is doing, and I think those are really interesting technologies, but also maybe too difficult for aviation. So I really see why Goodfuels is focusing on that because of the specification of that oil. But to upgrade a BTG oil, for example, with let's say 10 or 15% of oxygen towards a fuel that's 0% oxygen and ready to be taken by aviation is quite challenging. Yeah. So we're very keen to see that the project develop and then eventually do some tests whether we can do that upgrade. But at the moment, it's a bit too far out. Besides the whole STM specification or certification issue.
It's well understood. It's well understood. So with that question, I have one general question left, which someone has written, and I took it down. And it depends on Kristin and the management team if we should put a general question, which most of us would have ideas about. How is it with the time, Kristin?
Well, I would say if you guys have time, I'm very happy to stay in the office as well. That's I mean, the discussion is working so well right now. So
well, let's see. The question I had at the end of my table is that with politics actually concentrating very much on battery vehicles, EVs, do you see a chance your proposals in various sectors here will be taken up? I mean, in competition then with EVs. So let's say Michal, for example, looked at the engines and so on. Do you have a view on competition between adapting conventional IC engines to, or will that be, let's say, finally turned down because the EVs will take over?
Yeah, I would agree. Like the competition is pretty tough, and let's say the discussion between the internal combustion engines versus electric vehicles. So it's like the, let's say, very long debate, and I would say what we would need in the future. So that's kind of unbiased comparison of, let's say, those two powertrains. So internal combustion engines run on advanced biofuels, and on the other hand, electric vehicles. Because at the moment, many times in the legislation, so electric vehicles are counted as zero emission vehicles. And basically, with, let's say, current electricity mix and also the battery production, so we cannot say it's a zero emission vehicle. No. And, but I would say that, let's say, in the recent, let's say, years, so people are starting to realize that internal combustion engines are still an option for the future, and not the electric vehicle are not only solution for the future. One example might be the China, which is currently stepping back from the investments.
Yeah. Ayla, you had something to say there.
Yeah. Yes. I think if we could simply change the wording competition, it will already help quite a lot, because I do not think that they are competing against each other, as we have seen. I mean, they all have a role to play. Battery electric vehicles are, I think, a great way of reducing carbon emissions in road transport. However, the question is how far you can electrify the road transport. First, the cost of battery electric vehicles. Then, as Michal said, how far you can get renewable electricity to feed those vehicles, and you don't have pressure on the power market because of the demand needed. But it's more bringing the discussion from either or to all. I think we have to make the policymakers recognize that biofuels have a role to play, and they have a very important role to play in addition to battery electric vehicles. And can we change this perspective? Yeah, we will be presenting our results, involving in discussions with the policymakers, and then we have to see.
And here I would say that your well-to-wheel approach, I mean, that you really show that if you put a new electric vehicle on the road, I would say that somewhere in Europe you increase a power plant running on coal a little to actually make the power balance. So we need to actually build a lot of windmills to bring down the coal burning in this part of the world. And for me, it's a very unlogic situation that we add electric users to the grid if we don't work with the grid. So, but I know Eric has a view here, maybe. I know you have looked at this, Eric.
Yes, correct. Well, I think indeed there is an interesting perspective to it, because if we place the combustion engine in competition with the electric engine and the battery electric vehicles, then that is all about, let's say, local air quality issues mainly. That's the idea we sell here. And I think this is a transformation from one engine towards another, but I think it's different from, let's say, our aimed transition from fossil to renewable, in which we actually try to tackle the climate impact. And in a way, these two perspectives seem to collaborate to a large extent, except that when you only focus on the introduction of electric mobility, it doesn't go quickly enough. So in that sense, it's the end story of Ayla. From our carbon budget, that still remains stay under the 1.5 degrees or even the 2 degrees temperature rise. We need to, let's say, curb the carbon intensity of the liquid fuels, which will be dominant for the next 10 to 15 years, even in road transport. We have analyzed in the Netherlands that there are plans, of course, to increase the share of battery electric vehicles from the current 100,000 to about 2 million passenger cars in 2030, which would then be an equivalent of a quarter of our total passenger car market. Yet, in energy consumption perspective, that only is 5% of the total energy consumption. And if the remaining then would still be fossil-based liquid and gaseous fuels, we would go much beyond our, let's say, targeted CO2 emission levels in 2030. So actually, that's where we have to make this collaborative effort. And it seems, I think it should start with giving policymakers the understanding of these petajoule numbers of energy consumed in the sector. Those that are responsible with electric mobility have looked through the issues via the lens of local air quality and urbanization, and don't have, let's say, often the full perspective of what is the volume of energy that is in our system and how will it look like, even if you have your massive introduction of battery electric, which I think should happen. But then they need to understand that even in that sense, the majority of the fleets are still, let's say, liquid fuel-based engines, and you have to have a solution for that as well. And I think that is a message that we have to bring across to policymakers, and then it starts turning to be this end-to-end situation.
Yeah, Eric, I have a signal here from the organizer that there is something problem with the the sound, with the. I mean, I hear you very well, so I had no clue.
I also followed it very well. So
what about
it was clear for me as well.
What about you, Kristin? You there? What about the people at FNR? Do you have problems?
Yeah, it's perfectly fine. So it's probably only Stavros who has problems.
Okay, it's one of us. Anyhow, I mean, this issue, there should be a kind of I think we need to kind of end this very interesting story with all your specialists. It's been a great time to talk to you. I don't know if is Philip still there, I hope, or I'm sure he is. Are you there, Philip? Or he felt he did his work in the first part of this?
Yes, I'm here.
You are here.
No, I'm here. I just muted my my mic as we agreed.
As we agreed. I just wonder, what kind of things do you hear most here in this discussion? We've talked for 45 minutes now. Are there some special topics which you have felt, wow, this is important, this is not so much covered or discussed? I mean, I have my views, but it would be interesting to, if you have thought about that, just listening now for a while.
Well, as Stavros was saying, the audio is very bad from my side as well. So I've not picked up everything that you said, although I've have a flavor of what was discussed. I think we've reasonably covered the subject of advanced biofuels. It's just one question that I sent to Kristin anyway, as via an email. I'm still surprised by the debate we have about where is the cost for biofuel structure and use. We've got a perfect example in Brazil. Over 50 years now, more or less, a bit more than 40 years, they've gone from 100% oil, fossil, to about 40–50% ethanol in gasoline for the cars. And basically they've done it, and they've got certainly a lot of experience to share where the different efforts were made, be it in production, of course, ethanol production, then afterwards the infrastructure, all that we've heard about the pipelines for ethanol, which is the adaptation to the emissions, which we know is necessary if you want to go beyond 10% of ethanol in gasoline, to go to whatever, 20%, 30%, 40%, 85%. And I mean, I've years worked on the subject, any serious analysis of how that's been done. And I'm pretty sure that would be a very good exercise to do. And then afterwards, it would take away lots of the debates, endless debates and useless debates about where the effort is.
Good point, absolutely. And we have heard good talks from Brazilians now and then, and hear their story. And I sometimes take it up with automakers, because they have some problems to get over those 5 or 10% of ethanol, and say, what do you do with the cars running in Brazil? Are they special brands? I mean, there are the Volkswagens and the Renaults and the Volvos, and all of them are there. So there must be a solution to the blending. Of course, they may have some other emission demands or whatever, but still it's the same cars with, I'm sure, a little adjusted engines. I hear two things, and maybe that's my questions in a way, or my kind of key issues coming up, or maybe three. It's the investment problematic things with, if you only have quotas and those kind of things, I can tell you that is not bankable things. You cannot go to the bank and say there is a quota in the commission saying we should have so and so much biofuels in 10 years. A bank would just say, okay, that's interesting, but how are you sure you can use the quota? We don't see the safety in the investment in that. So I mean, the trick of actually attracting capital, even though there is a lot of rules and regulations about blending in biofuels, there is a key issue for us to move. Another one is what I try to raise, where actually are the big investments. And I challenge you to say that I would say almost 90% of the overall investment is in production. And then you can take the remaining 5–10% to infrastructure and vehicle adaptation. It's really in the production you have the costs. I did a calculation for Sweden with the 2,000 euros per kilowatt of fuel, and you have to invest about 160 billion Swedish crowns, about 16 billion euros, to change the system. And I'm sure that Scania and Volvo and the others, they will spend 1 billion euros something, or $500 million, to build a new factory for new engines to adapt. It's another order of magnitude in the vehicle adaptation compared to cost of production. And the same thing is for infrastructure. It's a fraction. But this is very little covered. And maybe you have reports and investigations which can help me to understand it better if I'm totally wrong. But I don't think I am. I think that's roughly where we are. The vast majority of money goes into production. So that's a very important issue. And then this electricity issue, which brought up at the end by someone, where we know we need to be much more careful on how to look at the whole chain, from making clean renewable power, producing batteries, and actually the vehicles, compared to what we have been talking about today. So 3 issues I would recommend to cover more. Okay, I now give over to Kristin and the team at FNR to finish this off. I thank you so much for participating.
Well, thank you, Ingvar. That was, it was a really interesting discussion, and that's why I don't think it was a problem for anyone that we, exceeded our time so much. But it was and really well moderated by you. Thanks a lot for this. And so it's about time to close now. I agree. I think everybody is getting tired a bit. I would like to present one last slide, and this is just announcing our next webinar. And I really hope I got our audience interested enough to promote these 2 events. They are actually on the same day. It will be a media briefing, which is directed mainly at journalists, but everyone else is also invited. And afterwards there will be a policy briefing. And these 2 webinars will be actually our final events, as the Advanced Fuel project is coming to an end. And in these 2 webinars, we will sum up our conclusions and recommendations, and try to display them as good as possible to a hopefully broad audience. And so please mark in your calendars the 24th of June. So it's already in 3 weeks' time, and so you can find all the required information on the Advanced Fuel website. We have also included here in the document section something to download, if you have maybe already seen this. Yes, and registration is also already available on the Advanced Fuel website. And we would like to, well, probably not see you again, because that's not possible. But if we could motivate you to participate once again in an Advanced Fuel event, I would be really happy if you would join. Okay, well, thank you very much for your contributions and for the participation, and hopefully see you next time. Thanks.
See you. Thank you.
Thank you.
Bye.
Bye.
Bye. Weg.